Okay. Right. Purundare is killed. I didn't ask anything yet. Yeah, tell me, am I audible? What about the clarity of the video and the audio? I didn't ask anything yet. Okay. Right. So give me 1 minute. I'll share the live to the group and come. Keep it silent. One more second. All right. Okay. Right. Good afternoon. We'll start. Right. Okay. We'll start. Right. Listen. Now, you all know that we had to take a holiday last week because of the flood disaster we had in the country, right? So for the areas like Colombo, Kalutara and overall southern province, the damage was kind of less. But for the areas like especially the central highlands, hill areas, mountainous areas like Kandy, Madale, Gampola, Padulla, right? And the dry zone as well. Dry zone like Mahayangana, Dehiyattagandiya, Trinco, right? All those areas were affected due to heavy rain, right? So I don't know whether you can remember in the paper class we had 2 or 3 weeks before. It should be 2 weeks, right? No, 3 weeks. Because one week we had a holiday, no? 2 weeks. Not the last week, not this week. Previous week was a holiday. Then the week before, yeah, 3 weeks before. On that day, can you remember that I said you that the storm is going to come on Thursday? Can't you? If you can't remember, you can go and watch the recording that day. Now, what I'm going to say is, I think I said the same in the paper class also on the Monday. What I'm trying to say is, now, as the responsible department, meteorological department was not that active those days. And what I believe is the impact of that, I know that's a disaster, I mean, that's a natural disaster. Even though it's a natural disaster, we can't make it zero, but can be minimized. Natural disasters can be minimized. I mean, damage can be minimized by taking certain precautions, right? So what I believe is, if they were more active and they were more concerned about the thing coming up, about the storm coming up, and if the awareness among people was given with some kind of thorough announcements, either to leave or kind of that, I believe that the damage could be minimized. That's the thing. Now, just as a general public person in the country, I knew it on Monday, right? The reason is I was not looking at the website, but the thing was the weekend before that weekend that the storm came, I went on a trip. So therefore, usually before we are going on a trip, as a habit, we check the weather condition, especially the rain and wind, right? Because usually we go on hikes now for mountainous areas. So that's why we are usually checking the rain and wind conditions. So when I checked the rain and wind the week before, I saw that it was updated on the website that it's coming on Thursday. I think it's more than 1 week before I saw it. And that's why I informed that I just give you that idea that it is going to come on Thursday, because the weekend before that week also, there was a kind of a rain, but that was not the storm. And all the details of the storm with the expected rainfall and the route of the storm and everything was updated there, right? I think I told you about this website in the paper class. This one, right? So there are two websites I usually check. One is this, and the other one was this. Other one is this earth.zoom. So in both of them, more or less the same details are same things, same information are available, and we can get an understanding, an idea actually, about what is going on, right? So before listening to the news, if you have the computer literacy or the technical literacy, right? So this is something you can use. That's why I'm just saying, because now in our generation, in the sense, if it's around, if the person is around, let's say, less than 35 years of age or something like that, right? So they are kind of familiar with internet and those things. So therefore, they can do this. And in our generation also, we are familiar. And when it comes to yours generation, right, you are more familiar compared to us. And the younger ones, compared to you, let's say 27, 28, 29 batches, they will be more familiar. That's how this trend goes. That's how the world goes, right? So therefore, just know these things, because this is not the last disaster that came. No, there can be more disasters in the coming years. We don't know in future, right? So therefore, it's better to have some idea about these things. I mean, before listening to news or before getting any news from any media, right? Because usually when it comes to media, sometimes they are not revealing the exact thing that's there, right? They are not revealing the exact thing, right? And now also, I think the death count is varying around 600 or something, no? Huh? 600? Huh? 700 or something, let's say. And the count should be around 1500 or something, because now misplaced count is also now already dead. And if the misplaced count is added, I think around 400, 500 something is misplaced, right? Then 700 plus 500 means එතනම තියෙන 1200. හරි? එතකොට තව උතන රෙකෝඩ්ස් වල නැති කට්ටිය. එහෙම කට්ටියක් ඉන්නවා. රෙකෝඩ් වෙලා නැහැ අර ලිස්ට් වල. This disaster is very much severe than we think. Very much severe than we think. Tam power outages areas right? Especially the areas they had to undergo landslides. Tam power outages right? Tam water cut water outages areas right? Flood which almost okay now, but for the ones who had to face landslides, in a landslide the damage is very much high. So therefore, to restore the facilities, infrastructure and everything, it takes some time. Now, with this government, they are doing it kind of faster compared to other ones, right? I'm not talking about any politics. I mean, just what I see is they are acting more faster, right? Bridges එහෙම ගොඩක් හදලා තිබ්බ මම දැක්කා. ඒක ඇත්තටම හොඳයි. මේ තාම ඒ වුණාට කරන්ට් අවුටේජස් කියන්නේ පවර් අවුටේජස් තියෙන පැති ගොඩක් තියෙනවා. water outages තියෙන පැති ගොඩක් තියෙනවා. right? So especially if you know someone, maybe your friends or anyone that who is who are struggling with the consequences of disaster, try to help them as much as possible, right? මේ time එකේ පුළුවන් තරම් ඉතින් help කරන්න තමයි තියෙන්නේ. If they seek your support in any terms, right? In any terms, like maybe by notes, right? This is not about money, not about donations. Donations means not about donating money, right? Not all about donating money, right? You can do anything, like providing notes, maybe tunes, right? Or sometimes listening to their calls, maybe small things, minor things, but it matters, right? So therefore, help each other during this difficult period, because the severity of the disaster is a bit heavier than that we think, right? Than we see, because I also personally went for donations on 2 days, right? Sometimes you might have seen if you are on my social media in the sense WhatsApp or Instagram, Facebook, those things, right? So I personally went 2 days for donations, and on the first day we went, the flood was still there when we go, and at some places we had to cross the flood and go to some isolated say areas or villages, right? එහෙම කේසුත් තිබ්බා, right? අපි first day මේ truck එක ගියේ, truck එකෙන් යන්න පුළුවන් සමහර තැන්වල, truck එකෙන් යන්න බැරි තැන්වල අපිට flood එකේ බහලා යන්න උනා. එහෙම තිබ්බා. හරිද? ඒ කියන්නේ අපි ගිය දවසේ දවල් තමයි ඒගොල්ලන්ට පොඩ්ඩක් හරි water level එක අඩු වෙලා තිබ්බේ. අපි ගියේ around 4:35 වගේ. ඊට පස්සේ 10 වගේ වෙනකන් අපි donations කරා. I mean 10 at the midnight night. So I saw the disaster in my own eyes. එන්දා ඒකේ severity එක අපි හිතනට වඩා ගොඩක් වැඩි, right? So there were some people who came for donations just with the cloth, just with the t-shirt and the bottom or whatever it is that they had on their body at that time. That's it. ඒගොල්ලෝ කිව්වේ මේ ඇඳගෙන ඉන්න එක විතරයි දෙන්නේ කියලා එන මිනිස්සු ඉන්නවා. ඒ මාර දුකයි ඉතින් දැක්කට පස්සේ. මේ ඉතින් ඒ ෆ්ලඩ් වෙච්ච කට්ටිය ෆ්ලඩ් එක විතරක් ලෑන්ඩ්ස්ලයිඩ්ස් නැතුව. මොකද අපේ ඒරියා එකේ වැඩිපුර තිබ්බේ ෆ්ලඩ්ස්. ලෑන්ඩ්ස්ලයිඩ්ස් එක අඩුයි ඒ පැත්තේ එච්චර හඳු නැහැනේ. ඉතින් ලෑන්ඩ්ස්ලයිඩ්ස් කට්ටියගේ ඩිසාස්ටර් එකේ ඒ කියන්නේ ඩැමේජ් එක ඊට වඩා ගොඩක් වැඩි. right? මම පොඩි වීඩියෝ එකකුත් දැම්මා මේ ස්ටෝම් එක කොහොමද ඩෙවලොප් වුනේ කියන එක. නිකන් ෆ්‍රී වෙලාවක් ගිහින් බලන්න. because there is some physics behind it, right? Bernoulli part එකකුත් තියෙනවා, fluid dynamics. ඊට පස්සේ thermal physics වල part එකකුත් තියෙනවා that is coming up, right? Anyway, that's in our syllabus now. So that's why I put that video, right? මේ channel එකේ ඇදී වීඩියෝ එකේ සමහර කට්ටිය බලලා තිබ්බා. මට සමහර කට්ටිය message දාලා තිබ්බා බලලා. මේ ඉතින් දැක්කේ නැත්නම් බලන්න, මම ආයේ explain කරන්න යන්නේ නැහැ දැන්. මේ අන්න ඒ විදිහට තමයි මේක develop වුනේ. මේක develop වෙච්ච විදිහේ තියෙන physics එක, the physics behind DITWA, right? ඔය cyclone එකේ තියෙන physics එක මොකක්ද කියන එක මේ වීඩියෝ එකේ තියෙනවා, නිකන් බලන්න. Because that's better to know as students who are learning physics, right? දැන් අනිත් අයට ඔක් කියලා දුන්නට තේරෙන්නේ නැහැ නේ. Bernoulli's theorem දැනගන්න ඕන, hygrometry පොඩි part එකක් තියෙනවා. එහෙම, right? thermal වල part එකක් hygrometry කියන්නේ. මේ එහෙනම් ඉතින් as physics students you should know these things. Yeah, common sense තමයි, but there is a physics behind it. කියන storm එක කරකවන විදිය, storm එකේ pressure decrease වෙච්ච විදිය, ඒ ඔක්කොම physics, right? Okay. And one more thing, මම කියවනේ one donations වලට කියන්නේ. So which means you also have contributed ලා. මම ඒක paper class එකෙත් කිව්වා මේ ඒ කියන්නේ දැන් මම donate කරන්නේ මගේ සල්ලි වලින්නේ. I'm donating by my money I have, personal money, right? Personal money කියලා කියන්නේ those are the things, those are the amounts that is coming to my accounts through classes, right? ඒ කියන්නේ ඕගොල්ලෝ ඇත්තට මේකට contribute කරලා ඉවරයි. So be happy about that, because if I engage, which means you have already engaged there for the donations. For donations වල ඕගොල්ලන්ගේ contribution එකක් එතන තියෙනවා. මම donate කළා කියන්නේ ඕගොල්ලන්ගේ contribution එකක්, right? So just know that and be happy about that. That is not about money. මොනවා හරි උදව් කරන්න පුළුවන් විදිහට හැමෝටම උදව් කරන්න. and ඔයගොල්ලෝ දකින්න ඇති මම flyer එකක් ඔය මේ flood week එකේ දැම්මා for the students who have affected from flood and the landslides and this disaster basically, right? So what we can do from our side is I can let them join to the class free up until they are sitting for the exam, not for just month or 3 months or 4 months, up until they are sitting for the exam. Doesn't matter whether they are 26 or 27, right? 26 නම් 8 months නේ, 27 නම් තව ඊට වඩා ගොඩක් තියෙනවානේ, 28 නම් around 1 year and 8 months no, right? Again around 20 months එහෙම time එකක් තියෙනවානේ. So up until they are sitting for the exam, I can make it free, entirely free for them, with everything that you are getting, all the tutors, facilities, everything that you are getting. So ඒක free වෙනවා කියලා කියන්නේ අත්‍තරම in terms of my side there is a cost component adding. එතන cost එක cover වෙන්නේ නැහැනේ, but that is what we can do from our side. So ඒක as a support that we can do, right? So therefore if you know someone who is seeking that, right? ඒ කියන්නේ යාමයි class එකට ආවා කියලා මට අත්‍තරම කිසිම දෙයක් හම්බ වෙන්නේ නැහැ. ඒකේ ළමයාට වෙන benefit එකක් විතරයි, right? තොර තනිකරම සපෝට් කරන මේකෙන් තමයි මම ඒක මේ ඒ වීක් එකේම දැම්මෙත් ඒකයි. මොකද කට්ටිය මේ සෑහෙන මම මතක කට්ටියගෙන් මම පර්සනලි මෙසේජ් කරලා අහලා බැලුවා මේ ක්ලාස් එකේ කට්ටියක් දන්නේ නැති සමහර කට්ටියගෙන් මට මතක් වෙන කට්ටියගෙන් මාතලේ කැන්ඩි කියලා සමහරලාට මතක් වෙන අයගෙන් මම අහලා බැලුවා මේ how was the condition කියලා. මේ ඊට පස්සේ සමහර කට්ටියගෙන් අතර මට හැමෝගෙම සමහරලාට ඇඩ්‍රස් මතක නැහැ. ඇඩ්‍රස් කියන්නේ මට එහෙම සිටිස් මතක නැහැ හැමෝගෙම. මේ ස්පෙෂලි ඔන්ලයින් ක්ලාස් එකේ ඉන්න කට්ටියගේ අර මම පෝස්ට් කරද්දි දකින්න ඇඩ්‍රස් එක තමයි. එතකොට සමහරලාට හැමෝගෙම මතක නැහැ. මට මතක අයගෙන් අහලා බැලුවා. සමහර අයගෙන් අහන්න බැරි වෙලා තිබ්බා. මට මේ ළඟදිත් 27 batch එකේ එක්කෙනෙක් message එකක් දාලා තිබ්බා මේ she is from Gambola and on last Friday only their flood level has decreased completely. and Friday තමයි ඒගොල්ලෝ මේක ක්ලීන් කරන්න පටන් ගන්න තියෙන්නේ. මේ එයාගේ ගොල්ලන්ගේ house එක. ඒතර මට එදා message එකක් දාලා තිබ්බා මේ all notes and tutors are all are gone කියලා. කියන්නේ කෙලින්ම ලොකු level එකකට වතුර ඇවිල්ලා ඒගොල්ලන්ගේ එහෙම එකක්. මම ගියා මම tutors එක ආපහු සේරම ටික දෙන්නම් මේ notes එයා කාගෙන් හරි ඉල්ලගෙන ආයි note එක complete කරගන්නම් කියලා කිව්වා. මේ ඇත්තට මට message එක දාලා තිබ්බේ she was asking for tutors again, right? tutors එක කොහොමත් මට දෙන්න පුළුවන්. And in addition, what I need to say is if you know anyone that who is seeking that, you can share that flyer with them and ask them to join the class, right? No conditions are applied. මොකුත් නැහැ. ඒගොල්ලන්ට ඇවිල්ලා class එකට join වෙන්න පුළුවන් until the exam, right? මොකද මේ ලොකු disaster එකක් ඒක. This is the most severe disaster we had in recent years after tsunami. Right? කියන්නේ natural disaster එකක් විදිහට. COVID was there, but COVID කියලා කියන්නේ ඒක natural disaster එකක් නෙමෙයිනේ. It's a pandemic no. natural disasters වලින් පස්සේ floods තිබ්බා. මේ level එකේ floods තිබ්බේ නැහැ. Right? That's the thing. 2016 flood එකක් තිබිලා තියෙනවා. හැබැයි මේ 16 flood එකටත් වඩා මේ පාර flood එකේ පොඩ්ඩක් severity එක වැඩි. Flood levels are sometimes less, but the landslides were very much high compared to 16. Thunderstorms. I didn't get the point. Right? So by the time of tsunami, you were there, right? You are 2008, 7. Right, 7 or 2004. I can barely remember what happened in tsunami because I was in grade no, grade 5. No, grade 3 or something. Yeah, grade 3. මට නිකන් බයාලේ මතකයි මොකක්ද උනේ කියලා. But in tsunami the thing was death counts are high, but it was just a come and go. ඒ කියන්නේ මෙහෙම මේ වගේ weeks ගණන් තිබ්බේ නෑ. This is happening for weeks now. Now still there are places where we have landslides. ඊයත් landslide එකක් වුණා in බදුල්ල, somewhere around බදුල්ල, right? ඒ කියන්නේ තාමත් ඒක impact එක තියෙනවා. And now the monsoon season is also started, and with that also now there's a rainfall, some kind of a rainfall happening in the central highlands, especially the areas like Kandy and Badulla, that area, right? So be safe anyway and help each other. And if anyone of you seeks any support in terms of anything, you can contact me. Feel free to contact me at any time if you need any kind of support. If you have faced any consequences of flood or any struggles regarding the flood and the disaster, feel free to contact me if anything. Tips එහෙම මොනවා හරි නැති වෙලා හරි එහෙම එකක් තියෙනවා. Right? Okay. Let's start. That's what I wanted to tell you before the class starts. And the other thing is මේ දැන් flood එකක් ආපු නිසා කියන්නේ, so as students you should know these things. As students කියලා කියන්නේ, now you are the ones who are going to get matured in 3, 4, 5 years here on. So therefore you should know these things. And since you have the literacy, definitely you should know these things. ඒ කියන්නේ දැන් මේ කියන websites ගැන එහෙම දැන් more than 40 years of age වගේ. ඒ කියන්නේ ඇත්තටම මේ අපේ අම්මලාගේ තාත්තලාගේ age එකේ කට්ටියට කිව්වා කියලා ඒගොල්ලන්ට ඒක ඇත්තටම comfortable නැහැ. කියන්නේ වෙබ්සයිට් එකකට ගිහිල්ලා මේක බලන එක ඒගොල්ලන්ට එච්චර comfortable නැහැ. එහෙම ලොකෝට මේ ඔය ඉන්ටර්නෙට් එක වෙබ්සයිට් එක වැඩ කරන්නේ නැහැ. හැබැයි අපි ඒක දන්නවනේ. So that's why I'm spreading the message. You know anyway. ඒතර ඔයගොල්ලොත් ඕක spread කරන්න. මේ මොකද සමහරලාවට sources තියෙනවා, right? Sources තිබ්බට අපේ කට්ටිය දන්නේ නැහැ එහෙම source එකක් available කියලා. Right? මේ මට තව example එකක් මතක් වුණේ. Now we have real time water level gauges in our main rivers. Right? ඒතර rivers වල gauges අපිට ඕන වෙලාවක බලන්න පුළුවන්. Right? මම නිකන් වෙබ්සයිට් එක කියන්නම්, පස්සේ වෙලාවක ගිහිල්ලා බලන්න. එතකොට මේ හදිසියෙ flood එකක risk එකක් තියෙනවා නම් don't wait until you are hearing that news out from the TV or radio. Don't wait until that. Right? Just go there and check it out. Go to our Department of Irrigation. In Department of Irrigation website, when you go below, there's a button called real-time water levels in major rivers. Right? Just go there and you can check the readings of water gauges. Right? මගේ මේ tabs ඔක්කොම ඔය දවස් ටිකේ මම open තියාගෙන හිටියේ මේ අතරම මේ ඔය water levels ගැන idea එකක් ගන්න. flood වෙනවා කියලා හොඳටම දන්නවා. But even though the announcements are given, some people are reluctant to leave. Right? එහෙම cases තිබ්බා. එහෙම වෙලා අන්තිමට they have been rescued at the very last moment. Right? Because for some areas the water levels were around 3 times compared to last times. So therefore they didn't believe that it is going to go that high because they have past experience. හැබැයි if they were looking at the readings of the gauges, we can say that in another 30 minutes this area is going to flood. අන්න ඒ වගේ. ඒ history එක ඔක්කොම බලන්න පුළුවන්. එතකොට අපිට rate එක ගැනත් idea එකක් ගන්නවා. The rate of water rise. ඒ ඔක්කොම බලන්න පුළුවන්. මෙන්න මේ website එකේ තියෙනවා. Irrigation. You know what irrigation means, no? Something like this, right? Irrigation department's website. මේවා දැනගෙන ඉන්න. එහෙම gauge එක බලන්නත් පුළුවන්. Right? Because now as a learning that we learn from this disaster, if another flood comes, let's say after maybe 10 years or 20 years, we don't know, right? Just know these things. May gauges real time update, right? There are two types of gauges as automatic gauges and manual gauges. Automatic gauges are real time updated and manual gauges are updated per each hour. Right? In each hour it's updated. So history එක බලපුව ගමන් දැන් ඉස්සර මේ කැලණිය areas එහෙම flood වෙද්දි එතන gauge එක බලද්දි ඉතින් තේරෙනවා කොච්චර rate එකකින් වැඩි වෙනවද කියලා. හරියටම කියන්න පුළුවන් in another hour this is going to be this much and it is going to be flooded. අන්න එහෙම idea එකක් ගන්න පුළුවන්. So just know this. right? Disasters බලන්න විතරක් නෙමෙයි. Say you are going on a trip to somewhere next week maybe. So next week you are planning to go on a trip to Norelia, right? So doesn't it good to know whether it's raining or windy or what's happening in Norelia next week, right? So that's why just know these things. Okay, let's start. Now, few more announcements are there. This week onwards, as I have been telling you in the paper class, now you are starting to write papers separately on a separate day, and you are going to get the graded papers on the day of the discussion, right? So therefore, if you are coming to the institute to write the paper physically, you can come here to Meshma or the Lisa Institute Horner during Monday to Thursday. Now it's extended anyway, right? So initially for Meshma it was Monday and Tuesday only, but now up to Friday, up to Thursday actually, up to Thursday or Friday is also fine. You can take and you can write the paper and keep it here or hand it over to the office, and I'll be collecting all papers by Friday, right? And it will be graded, and you are going to get the graded paper by Monday before the discussion, right? So that is how it is going to go this week onwards. So therefore, allocate a time. Even if you are writing online, you also have the same dates available from Monday to Thursday until Thursday midnight, right? It's available on the website. You can go there and write the paper and submit it there, right? So whether you are writing physical or online, doesn't matter. All papers will be graded, then you are going to get the final mark by Monday. That's a plan, right? So therefore, now if you didn't submit the paper by Thursday night or before Friday, right? If I couldn't collect your paper, then I don't have any other means of taking it and grade the paper before Monday. So therefore, have a fixed date, a permanent time for you to write the paper, because it is going to happen in all the weeks coming up here onwards, right? So that's going to be a weekly thing, no? So therefore, allocate a fixed time, right? Doesn't matter which time that is, if you are coming to any other classes here or if you are going by, right? Sometimes as it is easier for you, you can write the paper, right? Papers are given to both institutes by now, right? And if you are writing online, for you also, time doesn't matter, but what I recommend is, what my advice is to you, to keep a fixed hour. Let's say now you have to write the paper on Tuesday from say 7 to 10, then try to keep that as a fixed time in all the weeks, then you won't miss it. Otherwise, if you miss writing the paper, right, grading and everything is going to be kind of messed up, and by the next week, I don't think it's that much practical to write 2 papers at once, because if you are writing 2 papers, it takes around 5 hours, 6 hours of time, right? So therefore, complete everything in the weekly basis, right? දවස් 4ක් තියෙනවා කියන හොඳම ඇතිනේ. You have 4 days to write the papers, right? මම මාකින් වල දවස් 2යි දැන් තියාගෙන තියෙන්නේ. මාකින් වල දවස් 2යි තියෙන්නේ. අතරම දවස් 2ක් මදි වෙයි සමහර විට. හැබැයි ඕගොල්ලන්ට දවස් 4ක් ලියන්න දෙන්න හින්දා තමයි මාකින් වල දවස් 2ක් තියාගත්තේ. Friday මම කලෙක්ට් කරගන්නවා කියලා කිව්වේ ඒකයි. right? Thursday වෙනකන් තමයි institutes දෙකට මම දෙන්න කියලා කිව්වේ. right? All right. Online එකටත් එහෙමයි. Up to Thursday midnight you can write the paper and do the submissions, right? I saw some of the online students they have submitted already, right? මම බැලුවා සමහර අය දාලා තිබ්බා. Physical students සමහර අය මට paper එක ලියන්න ආවා කියලා message දාලා තිබ්බා, because for the first time they are writing a paper on a different time, no? That's why. So after this week, make it a habit. So you'll be writing it in a weekly basis, right? ඒක තමයි first thing එක about the paper class. And about this class, I think I informed about the reverse class that I'm planning to start. In this class, the last class we had might be in the paper class. I can't remember where, but for your batch, I told you that we are going to start a reverse class as well, right? So just know that we are going to start the reverse class by January, right? By January, I'll be starting the reverse class. In reverse class, what we are doing is I'll be covering the lessons from the back end of the syllabus that they don't have much links with the previous ones, right? So therefore, you will have to join 2 classes per week from January onwards, right? 2 classes per week. In both are 2 theory classes. This is the forward class, right? Forward class, and that will be the reverse class. And for the revision students also, I'll be joining all of them to the reverse class, and all the theory students, you also can join the reverse class. I mean, once you are registered to the theory batch, right, you can freely join the reverse class. No need to purchase, nothing like that. Nothing like that. You also can join the reverse class, right? And you must join the reverse class. මම එතනින් back end එකේ තියෙන theories ටිකක් cover කරනවා. Then we'll be covering 2 weeks, maybe 2 lessons in a given week, in a particular week, right? 2 units, 2 lessons in the sense 2 units basically, right? Okay, so those are the things I wanted to inform before starting the class. Okay, let's start now. So far in optics we have covered up to refraction through prisms, right? Now we are still in the refraction. This is the last part of refraction. What is refraction of light, by the way? What is refraction of light? Bending of light due to change of media, right? Change of medium or change of media. Bending of light, the phenomenon of bending light due to change of media, that is called refraction, right? So in first day and the first 2 days actually we were discussing about the normal refraction, right? What generally refraction is, an apparent depth, real depth, that was a start. And then after that we came to refraction through prisms, right? That is also an extension, that was an extension of refraction, and specifically that is about refraction through prisms. Refraction through prisms, because in prisms there are different things and special things, unique features when it comes to prisms. Minimum deviation and about emergent rays, deviations, minimum deviations, right? Prism angles with different jargon and different things, right? So that is why we had to discuss about the refraction through prisms separately, because there are unique things about prisms when it comes to prisms and color dispersion, right? So everything we discussed. And now we are in the last part, last arm of refraction, that is refraction through lenses. The reason to study about lenses separately is, when it comes to refraction through lenses, there are some unique features which are only valid for lenses, which are only with the lenses, right? So therefore, unlike the normal refraction through a glass cube, when it comes to lenses, so you know we have 2 types of lenses. No, what are the types of lenses you have heard about, you have come across? Convex and concave, right? Convex and concave, yeah. So with the convex and concave lenses, right, there are some special features in light, in optics, that we need to look for. That's why we have to discuss about refraction through lenses as a separate lesson, right? Okay, so as a heading, write down refraction through lenses. 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 Right. Listen. Listen. One more second. Okay, listen. Refraction through lenses. So as I told you, there are only 2 types of lenses we have. Only 2, right? 2 general types, convex and concave lenses, right? So I'm sure that all of you have heard about these 2 types, convex and concave. Convex and concave, right? Convex is this kind of a shape. Lenses are made of what? Lenses are made of glass, right? So this is also lenses. Huh? These are lenses. So in cameras, we have lenses. තාම ටියුට් එක හම්බුන්නේ නැහැ. ටියුට් එක කව පේජ් එකේ කැමරා එකක් දාලා ඇති. දැන් මේ YouTube thumbnail එක බලන්න දැන් යන කැමරා එකක් දාලා ඇති. Everywhere we have lenses. Even in this camera, there's a lens, right? So this is also a lens. If you are wearing spectacles, which means you are wearing lenses, right? So if you are doing photography, that's also lenses. And even in the phone, na? So here, these are lenses. All of them are lenses, right? And the hand lens you are using, lenses. Hand lenses are known. And microscopes, telescopes, right? Anything. Everywhere you have lenses, right? Now we are going to learn about the behavior of light rays through lenses, specifically here, because there are some unique things about lenses that we need to check for, right? So this type of lenses are called convex. Now here the glass medium is this is made of glass. These shapes are called convex shapes. And if the curvature is to the opposite side like this, that is called concave. Right? Now, don't draw this. We are going to see what happens if this glass block is, now this is made of glass, no? If a glass block is cut in this shape, मैं cut करला दिए, मैं glass से cut करला दाएं में कहाँ जाना है? Glass block क्या करा? मैं cut करला दिए. To this shape, prism में खदान लेते हैं मैं. Prism is a cut glass. This is also a cut glass. Got it? That's a cut glass. तर මෙහෙම glass එකක් cut කරාම මේක lens එකක් විදිහට වැඩ කරන්නේ කොහොමද කියලා තමයි බලන්න හදන්නේ. Right? How this is going to behave as a lens when this is cut, right? Okay, write down as a subheading number 1, convex lenses. Subheading number 1, convex lenses. Convex lenses. Convex lenses. Convex lenses. Subheading number 1, convex lenses. Okay. Now, basics behind here is, because these refraction through lenses, this is none other than refraction. So therefore, basic behind this is refraction, right? So I hope you have gone through all the parts that we covered so far in refraction, because the fundamental, the basics here are about the refraction. These are refraction again through a lens, right? Forget about the lens part for now. This is about refraction. Then all the theories regarding, all the concepts we learned regarding refraction are all valid here. Everything is valid here, right? Okay. Now look at the board. Don't write this down. Don't take this down. Just look at the board. Say this is a convex lens. This is a convex lens, right? Now you can see the convex lens is made of two curved surfaces, no? Right? Two curved surfaces. Now I'm going to complete these curves. See, I'm going to complete these curves. Anyone can remember the word that we are saying for this axis which goes through the center of the lens? What we call this? You know this from O levels. What is this? Principal axis. Good. Principal axis. This is called the principal axis. මේක දන්නේ නැත්නම් මේක O levels වල තියෙනවා. This is called the principal axis. Principal axis. The line which goes through the center, exact center of the lens is called the principal axis, right? Now, I'm going to complete these two curves of this lens. See, I'm going to complete these two curves of the lens. I'm going to complete these two curves of the lens. Because if the lens is made of two circles, right, two curves, these two curves should have two circles like this. There are some associated circles like this, right? So if you are using compasses, you can use it. I mean, if you have, right? Now, I want you to do something. Look at the board. Look at the board. I want you to do something. Now, I'm going to draw a light ray which is coming towards the lens like this, right? Forget about everything that you know about lenses now, lenses for now, right? Converge වෙනවද, diverge වෙනවද, ඒවා මුකුත් එපා. Forget about everything, right? ඒවා මුකුත් ඕනේ නැහැ. You know refraction, no? right? You know refraction. Now, podi hint at then. Now, if I consider this ray, now I need to do the refraction of this ray at this point. Then first of all, we need to draw refraction. What we need? What we need? Normal. You need the normal, right? Now, if this corresponding circle is this one, its center should be somewhere here. No? Let me label its center as O2 and this one's center as O1, right? O1 and O2. Now its center is here. If a normal is drawn to the circumference of a circle, it goes through center. It goes through center. So therefore, if you draw the normal here, like this, definitely it should go through the center. Right, this is visible, no? Right. It should go through the center. Now tell me, this glass, no? This is made of glass. This is a lens. Lens is made of glass. This is air medium. So the light ray is coming from air to glass. If that is coming from air to glass, what's the bending? Air to glass, air to dense. What's the bending? Towards the normal, not center. Towards the normal, right? Light ray, it should bend towards the normal. Towards the normal means a direction like this, right? Then this is another surface where it is going to go to the air medium. That is an interface. Then there should be another refraction here. No? Then to draw the refraction, draw the normal and complete the refraction. Refraction, right? Now this is a small task and the first task for the lesson that I am giving you, right? Complete the refraction for this light ray given. Complete the refraction of this light ray given. Complete this, right? So this is where you are going to see the exact concept behind a lens. දැන් අර පොඩි කාලේ O levels වල සමහරට කියලා ඇති මේ මොකද convex lens එකකට આવත් converge වෙනවා එහෙම කියලා තියෙනවනේ. දන්නවනේ. If a parallel light beam is fallen onto a convex lens, it is going to be converged, right? If a parallel beam of light is fallen onto a concave lens, it is going to be diverged. O levels වල ඔහොම කියලා ඇති. එහෙම කිව්වා කියලා ඒක මේව කරන්න බෑනේ. This is the verification of that. මෙතන තමයි ඒකේ concept එක තියෙන්නේ. Concept is all about refraction. So that's why I'm asking you to draw this. Draw this quickly. Take this down and complete the light ray. If you have finished that, you can complete this second light ray as well. If you have finished the first light ray, complete the second light ray as well. 2 minutes. මේ paper එක submit කරපු නැති කට්ටිය ඉන්නවා මේ paper එක submit කරන්න, right? I mean the online ones, right? paper එක submit කරන්න. late submission එකක් වුණත් කමක් නැහැ කරන්න, right? online එක late එකක් කියලා කියන්නේ මේ week එක next week නෙමෙයි. පොඩි වෙලාවකින් ඒක late submission එකක් නම් කමක් නැහැ. That also I will consider, right? So therefore don't just wait without submitting it, right? Take this advantage when someone else is going to grade your paper, right? Some stranger. මමත් නෙමෙයි බලන්නේ. ඒතකොට සමහරට ඔයගොල්ලන්ගේ නමවත් දන්නේ නැහැ. ටික දවසක් බලද්දි මෙහෙම නම් දිනනවා කියලා දැනගනි, right? Some students from 25 batch is going to mark papers, is going to grade papers, right? Under my guidance, right? So therefore, when someone else mark your papers, right? That is an advantage you can get. That's the exact same scenario you are going to get at the exam. Your paper will be marked by a stranger. You don't know, right? Okay, finished? Okay, what's happening here? Now, if you draw the normal here, this normal should go through the corresponding center of this circle, isn't it? Right? Because this circumference belongs to this circle, right? Then if you draw the normal there, it goes through this center like this, right? And here, this refraction is from glass to air. It travels away from normal. It bends away from normal. Now, the normal is this. It bends away from normal. So, it goes away from normal to a direction like this. Got it? Now, do the same for this one as well. And I'm again looking for a day for the waves practical seminar because I actually fixed a date, right, with the institutes in the last week of December, right? That's the exact week where the flood disaster came. That was the thing. That was the thing. මම last week එකේ institute එකත් එක්ක fix කරගත්ත date එක. flyer එක share කරලා තිබ්බේ නැහැ. flyer එක share කරේ නැහැ. මම flyer එක එදා තමයි share කරන්න ගියේ. right? flyer එක share කරන්න කලින් තමයි disaster එක උනේ. Okay, what about this one? This circumference belongs to this circle. So this is the normal here. And it bends. See, this is coming from glass to air to glass medium. Air to glass medium. So it bends like this. And if you draw the normal here, oh sorry, my normal is wrong. If you draw the normal here, see, this normal goes through this side like this one, no? So it bends towards the normal. And if you draw the normal here, right, same thing happens, and this normal goes through this point O1 and it bends away from the normal. It bends away from the normal, right? If these gaps are same, you are going to get the intersection of these two on the same point on the principal axis, at the same point on the principal axis, if the gap is same. If the gap is same. Correct? Complete it. Right. Now, there's nothing here other than a normal refraction, a general reflection. There's nothing here other than a refraction. Right? Then make a convex lens එකක්ද concave lens එකක්ද කියලා අපි හිතලා නෙමෙයි මේක ගන්නේ. Right? Just by looking at the bending, whether it's towards or away. මෙන්න මෙහෙමයක් ඇවිල්ලා තියෙනවා. Right? So this is what is going to happen if parallel light rays are coming to fallen onto this lens, a convex lens, right? So they are going to be converged here and further converged here, and the ultimate result is they are going to be converged, right? So therefore, for our ease, listen carefully, for our ease, we are not drawing both refractions when we are drawing the lens here onwards. Now, we know the takeout, we know the learning from here, no? So we are taking this learning from here. With the learning, this is what we are going to draw, right? I'll be erasing this. With this learning, this is what we are going to draw here onwards, right? This is the principal axis, and this is the convex lens, right? This is the convex lens, and if parallel beam of light falls, they are going to be converged, something like this. But this is not something you should parrot, right? This is how it came out, right? ඒකේ මම මේක ඇදලා පෙන්නුවේ. දැන් O levels වලින් ඔයා දන්නවා මේක converge වෙනවා කියලා. But why it is going to be converged and how it is going to be converged? So this is what is behind it, right? Machines වගේ මේක පාඩම් කරගන්න එපා. ඒකනේ මේ මෙතන point එක. Know the concept. මේ තියෙන්නේ normal ordinary refraction එකක්. This is an ordinary refraction, right? So දැන් මේ දෙකම අඳින්න නැතුව අපි for our ease we are sticking to this, right? So therefore here onwards we will be following this when we draw this. හැබැයි ඒක ආවේ මෙන්න මේ විදියට. So how many refractions are happening in a lens? How many refractions? 1 or 2? 2 refractions. There are 2 refractions. Not 1. There are 2 refractions. Right? දැන් මෙතනින් මේක පේන නිකන් එකයි වගේ නේ. අපි මේ lazy එක තමයි මෙහෙම අඳින්නේ. Having this learning. මේක තමයි learning එක. Right? Just know this. මේක තමයි මේක දැනගන්න ඕනේ. මේ ගොඩක් අය කියලා දෙන්නේ නැහැ. අත්‍තරම කියලා දෙන්නේ නැහැ මේ ගොඩක් අය. සමහරවිට ඔයගොල්ලෝ අහලම නැතුව දැන් lens ගැන දන්නේ grade 9 විතරයි දන්නේ. නේ? 9 or 10 කියන්නකො 9 වගේ. grade 9 වගේ දැන් lens ගැන දන්නවනේ. O levels වල විතරක් නෙවෙයි A levels වලවත් මෙන්න මේක වෙන්නේ කොහොමද කියන එක ගොඩක් අය කියන්නේ නැහැ. මෙතනින් තමයි පටන් ගන්න. ඒතර එහෙම වෙන්න එපා. physics behind this is here. මේක තමයි මේකේ තියෙන අතර physics එක. right? physics වල prove කරන්න බැරි දේවල් නැහැ. everything can be proved. right? facts නෑනේ. facts අඩුයිනේ. facts අඩුයි. මේ fact එකක් නෙවෙයි. this is not a fact. this is a concept. it is coming from here. what the point? කියලා දැන් මෙතනින් පස්සේ මේක මතක තියාගත්තර කමක් නැහැ. convex lenses are going to converge light rays. හැබැයි ඒක converge උනේ fact එකකින් නෙමෙයි. this is how it happened. right? okay, take this down. If you have some space in front of this, you can take it down in front. If not, take it below this diagram. right? So I'll label these two again. This is called principal axis. Principal axis. And this point is called, now this is a special point of the lens. This is called F. What is F? Focal point. Focal or focal point. Right? So this is called the focal point. Label both. So we will see what focal point is. That is called focal point. F. Focal point. F. Focal point. What about the ones on YouTube live? You all with me, right? All good? Is it all good? The ones on YouTube? Anyone? One more thing, not about the lesson, one more thing. Since some of the students from this class, from your class, were inquiring about the revision class I started yesterday, and online one is happening on Wednesdays, and the physical class at Lisa is on Wednesdays, and physical class at Mashma is on Thursdays. Yeah, good. Okay, good. On Thursdays, since some of you asked about it, right? So what I need to say is, if you were in this class from the very beginning, right? From the beginning, from the first month, if you were here, it's guaranteed that you don't have any gaps in your theories, right? So which means you know all theories, right? So therefore, for the students like that, what I recommend is, you better practice more questions by writing papers and or by as doing your own questions and by writing papers with me, right? That is better rather than spending 6 hours to 6.5 hours in the revision class, right? Because in revision class I'm doing all theories from zero, right? But if you already have theories, I don't think you need to duplicate it by being in a class physically or physically or virtually, I mean for 6 hours. Right? ඒක 6 hour class එකක් නේ. එතකොට ඒක ටිකක් ලොකු time එකක් නේ. Right? Now, if you already got the theories, if you know the theories from the first month, if you are in this class from the first month, right? 100% theories are there. So, our theory මතක නැත්නම් that problem is with you, which means you haven't gone through. Right? ඕක තමයි තියෙන්නේ. But there are some students who have joined the class maybe some months after the beginning, after the commencement, right? Or maybe in the last month, 2 months before. කොහොම කට්ටිය ඉන්නවනේ. අර පස්සේ join වෙච්ච කට්ටිය. අන්න ඒ අයගේ මුල theory parts වල ප්‍රශ්න තියෙනවා නම් if you have any issues in the theories about the lesson unit 1, unit 2, unit 3, right? 3 නම් තියෙන විදියක් නෑනේ ගොඩක් වෙලාවට. 3 කියන්නේ දැන් අපි තාමත් යන්නේ 3 නේ. right? 3 එකෙත් මුල ඒවා තියෙනවද කියලා දන්නේ නැහැ. unit 1, 2, especially mechanics වගේ units වල ප්‍රශ්න තියෙනවා නම් join වුණාට කමක් නැහැ. right? හැබැයි theory තියෙනවා නම් මම කියන්නේ ඔයාලට ඒක ඕන වෙනක් නැහැ කියලා. right? හැබැයි ඔයාලට join වෙන්න ඕනම නම් you can join. right? you can join ලා බලන්න පුළුවන්. idea එකක් ගන්න ඕන නම් ඒක යන විදිය මේ yesterday recording එක ඇති YouTube එකේ ඒකත් බලන්න class එක කොහොමද යන්නේ කියලා. The speed is around 4 times faster than faster compared to this one. No? Again, revision class because that plan is to finish the syllabus in 35 weeks. Right? 35 weeks, 8 months. Whether you are in the theory class or revision class or whatever it is, both of you are going to be joined with the reverse class. The reverse class again content is same. Syllabus coverage at the same point. මොකද මගෙන් ඊයේ කෙනෙක් කවුරු හරි ආවා මේ ඒකේ කලින් සිලබස් කවර් වෙනවද කියලා රිවිෂන් ක්ලාස් එකේ. එහෙම වෙන්නේ නැහැ. right? රිවිෂන් එකේ වුණත් තියරි එකේ වුණත් සිලබස් කවරේජ් will be at the same point. right? ඒක මොකක් හරි වෙන month එකේ මේ දෙකේම එකම classes දෙකේම එකම point එකක තමයි ඔය කවර් වෙන්නේ. අරකේ කලින් වෙන්නේ නැහැ. right? ඒතර ඒ හින්දා join වෙන්න ඕනම නම් join වෙන්න පුළුවන්. no worries. මේ මගෙන් 4 දිනක් වගේ මං හිතන්නේ ආවා. ඒ නිසා මම මේ කියන්නේ මේ theory තියනවා නම් theory ටික හොඳට බලලා questions try කරන එක ඊට වඩා හොඳයි. ඒ කියන්නේ අතන 6 hours ඔයා class එක rather than sitting in a class for 6 hours. right? So I think theories කියලා දැන් එතන අලුත් theories නෑනේ. theory is same. right? theory එක කොහොමත් same. now say linear motion, I started with linear motion last day. all the concepts and theories of linear motion is same. linear motion එක revision class එකේ කරත් 27 class එකේ කරත් 28 class එකක කරත් 29 කවදා කරත් linear motion theories are same no. that's the thing. different questions තියෙන්න පුළුවන්. revision class එකේ discuss කරන්න. හැබැයි ඊට වඩා questions වල discuss කරගන්න පුළුවන් නේ මොනවා හරි particular lesson එක paper එකෙන් paper class එකෙන්. paper එකේ කොහොමත් ඒ වගේ questions තියෙනවනේ. ඊට වඩා තියෙනවනේ. now if you are writing the MCQ this week, there are 50 different MCQs there. So එතන mechanics වල MCQs තියෙනවා සාමාන්‍යයෙන් like 12 to 13, 12 to 14 වගේ mechanics MCQs තියෙනවා. That's a good amount. එහෙම තමයි වෙන්න ඕනේ. right? so therefore if you really need to join, you can join. right? දැන් theory class එකේ ඉඳලා theory note එක complete නැති කෙනෙක් ඉන්න විදියක් නැහැ නේ. note එක අනිවාර්යෙන් තියෙනවනේ ඔයගොල්ලෝ ගාව from the beginning. ඒ නිසා මේ මම කිව්වේ ඕනනම් ඒකට join වෙන්න, but theory එක එතකොට ඔයාට ඇත්තටම මගෙන්ම recall කරගන්න ආයි ඕනනම් join වුණාට කමක් නැහැ. right? හැබැයි concepts are same, theories are same. right? that's the thing. මේ revision එකට join වුණා කියලා කලින් syllabus ඉවර වෙනවා කියලා එහෙම එකක් නැහැ හොඳ. දෙකම එකම විදියට යන්නේ. සමහර lessons වලට සමහරට මම revision එක මේකත් එක්ක join කරන ඒවත් තියෙයි. ඒ කියන්නේ reverse class එකේ කොහොමද join වෙලා තියෙන්නේ. ඒ අමතරව වුණත් දැන් හිතන්නකෝ by this month we will be starting thermal sites no. by the end of this month we are starting thermal. so thermal start කරද්දී සමහරලාට revision එකත් ඔන්න අපි thermal start කරන දවසේ මෙතන ඉන්න පුළුවන්. right? මොනවා වුණත් priority එක තියෙන්නේ. يعني priority එක කියලා කියන්නේ theory revision compare කරොත්, right? in terms of theories, more theories are discussed here in the theory class. එහෙම තමයි හැටි ඒක තේරෙනවනේ. this is a class of more than 2 years, right? For 2 years and 3 months wage, right? Revision is a class for 8 months, but still we have to do the same content. එතකොට ඔය පොඩි theory parts තියෙනවා සමහරවිට revision එකේ skip වෙනවා. හැබැයි everything from zero will be done. additional දේවල් තියෙනවනේ. අර දැන් මම මේ class එකේ කියන සමහර additional දේවල් තියෙනවනේ. additional දේවල් සමහරවිට ඒක miss වෙන්න පුළුවන්. right? okay. ඒතර මම ඒක කිව්ව idea එකක් ගන්න ඕන නම් ඊයේ recording එක බලන්න. එතකොට හොඳ idea එකක් එයි මේ මම කොහොමද මේ class එකේ කරේ. and එතකොට ඔයා දන්නවනේ මම linear motion මේ class එකේ කරේ කොහොමද කියලා. මම linear motion මේ class එකේ කරන්න I got 4 days. whole month. අපි එක month එකක් කරා linear motion. right? In revision only 1 day, 6 hours. Everything is done. Something like that. right? okay. මේ අහපු නිසා කිව්වේ මොනවා හරි තව clarifications ඕන නම් මට message එකක් දාන්න. right? මට message කරපු අයටත් මම ඒක කිව්වා. මේ දැන් සමහර කට්ටිය අතරම ඇහුවා මේ class එකට join වෙද්දී මේ mechanics miss වෙලා තිබ්බේ. ඒ කියන්නේ පස්සේ join වෙච්ච අය. ඒ වගේ කට්ටියට revision එක කියලා කියන්නේ හොඳ option එකක්. that is better. right? revision එකේ theories ඔක්කොම මම කරනවානේ. okay. that's it. write down below. label these two focal point and principal axis. write down below as a subheading focal point of a convex lens. focal point of a convex lens. focal point of a convex lens. any idea about what focal point of a convex lens is? this is how the focal point is defined, right? This is the point on principal axis on which all the parallel light beams are going to be converged. Is called the focal point of a convex lens, right? Doesn't matter how many parallel rays are fallen into this, all the rays are converging here, right? And focal point and this center point are two different points. එහෙම එකක් නෑ මේ center එක වෙනම තියෙන්නේ. පේනවනේ? Center point and focal point are two different things. okay. write down below the point on 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 principal axis, the point on principal axis where all parallel light rays are converged. You know the word, right? are converged is called focal point of a convex lens. 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 okay, listen. In optics, if an image can be taken onto a screen, that is called real. If an image cannot be taken onto a screen, that is called virtual, right? Now if we think of this focal point, listen, this is a good point. If you think of this focal point, right, if I keep a screen here like this focal point will be fallen onto the screen, no? right? That will be happening at the screen, on the screen, right? so which means this focal point is also real. Because focal point can be taken onto a screen, right? That can be taken onto a screen. Mention in red. Next point, write in red. Focal point of a convex lens is real. Focal point of a convex lens is real. Focal point of a convex lens is real. මම last week එකේ tudes post කරේ නෑ. හිතලම කරේ නෑ. The reason is there are some issues in postal services in some areas. මේ කොළඹ වල නැහැ. අනිත් areas වල තියෙනවා. Right? So therefore by this week only I'll be posting. Now everything is getting better day by day. Now it's okay. Right? මගේ delivery එකක් තිබිලා මම මේ pens වගේක් delivery එකක් තිබිලා අද තමයි ආයේ මම කිව්වේ උදේ සෞදි ක්ලාස් එකේ කිව්වේ මේ දාලා ටික දවසක් වෙනවා. සමහර delivery services උත් හරියට වැඩ කරන්නේ නැහැ මේ දවස්වල. Right? අද තමයි ඒක ආවේ. වෙන්දර දවසෙන් වගේ එනවා. දවසෙන් දවස් දෙකකින් වගේ maximum වෙන එකක් ටිකක් පරක් වෙලා ආය අර. ඒ වගේ තමයි මේ postal service උත් එහෙමයි. Now since it's getting better, so by this week I'll be posting all the tutes. නැත්නම් මේ tute එක misplace වුණොත් එහෙම අපරාධනේ. එතකොට මමත් එවලා ඊට පස්සේ ඔයාලට tute එක හම්බුනේ නැත්නම් ඒක අපරාධයි. Right? So that's why I didn't post in the last week. Okay, then heading to convex lenses, concave lenses. Heading to concave lenses. Concave lenses. Concave. Concave lenses. Right. Draw the principal axis again and draw a concave lens like this. A concave lens. How many curved surfaces are in a concave lens? How many curved surfaces are in a concave lens? Huh? That's also 2, right? That's also 2. So complete these two curves again, right? Complete these two curves again. See? Complete these two curves again. And let's label these center points as O1 and O2. Centers as O1 and O2. Right. So we are going to try the same. We are going to do the same. This is a parallel light ray which falls onto this surface, right? This surface, right? Draw the normals and complete refraction. How many refractions are going to occur? How many refractions? 0, 1, 2, 3. How many refractions? 2 again, because this is one interface and here there is another interface, right? Complete it quickly. No, last week paper class එක හිටියනේ. නේද? නෑ බා මම දැක්කේ නෑ. What happened? Huh? Goal. මේ discussions miss කරගන්න එපා. Right? Don't miss out the paper discussions. Right? So as you are writing papers by your own, discussion is also very much important. That is where you are going to see your mistakes. Right? And broaden your knowledge. ඇත්තටම paper class එකේ papers ලියද්දි තේරෙනවානේ. Even though you have a solid knowledge on theories, සමහර කට්ටිය ඉන්නවා theories හොඳට මතකයි. හොඳට theory ඔක්කොම මතකයි. But when it comes to questions, they get stuck. That's the nature in these science subjects, especially physics and maths. මේ subjects වල එහෙම තියෙනවා. Right? Just by knowing theories, that doesn't mean that you can tackle all questions. Right? So therefore, that is why you should be there. Right? Discussions එක miss කරගන්න එපා. මොනවා හරි discussions miss වෙලා තියෙනවා නම් recording එක අනිවාර්යෙන් අරගෙන ඒක within the week cover කරගන්න. Right? Finished. If you draw the normal here, it goes through O1. This normal goes through O1. Right? Okay. This is coming from air to glass. It bends towards the normal, like this, towards the normal. And if you draw the normal at this point, it goes through O2. Right? At this point, it bends away from normal. So away from normal, something like this. Something like this. If you extend this, right, it will come to some point on the principal axis like this. Right? And draw the second light ray as well. If you draw the normal here, it bends towards the normal like this. And if you draw the second normal here, it bends away from the normal like this. Like this. Right? If these gaps are same, both of the light rays will be virtually coming. Virtual means that is not coming in reality. Virtual means right? It is apparently coming. Virtual means that is apparently coming to a single point like this. This is the diagram I expected. Right? So therefore, listen. Therefore, here onwards, this is what we are going to draw as a concave lens. We are going to take the learning out from this exercise. We are going to take the learning out. What's the learning now? Finish it quickly. Right? Okay, look at here. Now, the learning is this. See, due to refraction, listen, due to refraction, if a parallel light ray comes, if a parallel light ray falls onto these two surfaces, right? Now, what has happened is, from the first refraction, it has diverged a bit, and from the second refraction, it has diverged further, and finally, this kind of a divergent has occurred, right? Now, from this side also, there's a divergent occurred, right? මේක lens එකක්ද මොකක්ද කියලා අපිට දන්නේ නැහැ මේ surface එකෙන් තමයි මේ වෙලා තියෙන්නේ. That's it. That is called a lens. That is called a lens. This is how a lens is going to diverge, a concave lens is going to diverge light rays. Right? That is a concept. That is a concept. මෙතන තමයි ඒකේ principle එක තියෙන්නේ. From the basics of refraction. So therefore, our takeout is this. Our takeout is this. If a parallel beam of light falls onto a concave lens, it is going to be diverged. It is going to be diverged like this. And they are apparently coming to a same point here. That apparent point of a concave lens is called the focal point. Right? This is not a real point. There is an apparent point. Apparent means it is there, but you don't see it. That is virtual. That is apparent. Right? Take it down. So same thing again. This is the principal axis. Principal axis. And this is the focal point. This is the focal point. Right. Take it down. So that is how this converging is happening. Converging and diverging. Converging in a convex lens and diverging in a concave lens. This is how it's happening. Right? This is the principle. For our ease only, we are drawing this. Right? For our ease only, we are drawing this. Right? Finished. Now here, there are something special. Look at the board. Now, say we need to take this focal point onto a screen. Then we have to keep the screen like this. Look at the board. Now, if you are going to keep a screen like this, right, what happens is all these incident light rays are going to be blocked by the screen, isn't it? මෙහෙම screen එකක් ඔයා තියෙනවා. ඉතින් මේ light rays මෙන්න මේ පැත්තේ දන්නේ. So once you keep the screen here, all these light rays are blocked, which means this is not going to form any divergence or form any image if the screen is placed here. Right? මේ light rays block වෙනවා. Light ray එක පටන් ගන්න මෙතන නෙමෙයි. Light rays are coming from somewhere here. Right? From a distance. Right? If you keep the screen here, it is blocked. Compare this with the convex lens. In a convex lens, it is not going to block. So focal point can be taken onto the screen. But here, if you are keeping the screen here, light rays are going to be blocked, and this focal point cannot be obtained because if the light rays are blocked, there is no focal point formed in that case. What's the point? So therefore, this focal point is virtual. This cannot be taken onto a screen. This cannot be taken onto a screen. Therefore, this is virtual. That's the difference between virtual and real. තේරුණානේ? දැන් සමහරවල්ලාට කටපාඩමෙන් virtual real කියන්නේ මොකක්ද කියලා ඉස්සර දන්නවා. ඔන්න ඕක තමයි virtual real එකේ තියෙන practicability එක. හරි? virtual image එකක් නම් once you try to keep the screen, light rays will be blocked. Right? And it is not going to form the image again. That is what we call as a virtual image. Right? Okay. Write down below the subheading focal point of a concave lens as the previous one. Same as the previous one. Focal point of a concave lens. Focal point of a concave lens. Focal point of a concave lens. Write down the apparent point. The apparent point, and underline or highlight the word apparent. The apparent point, that is not a real point. That is not an actual point. The apparent point. But in convex lens, it was an actual point that you would see. The apparent point on principal axis, the apparent point on principal axis, where the apparent point on principal axis where all parallel light rays, all parallel light rays, where all parallel light rays are converged, are apparently converged. Say apparently converged, that is better. Are apparently converged. Are apparently converged. Is called, are apparently converged is called focal point of a concave lens. Is called the focal point of a concave lens. Is called focal point of a concave lens. Focal point of a concave lens. Right? Write down with a red pen. Next point. Focal point of a concave lens is virtual. In red. Focal point of a concave lens is virtual. Focal point of a concave lens is virtual. Right. So did you see the difference between the real focal point and the apparent virtual focal point? Right. For images also, the same thing is applicable. If you need to check whether an image is real or virtual, imagine that you are going to keep a screen, place a screen there. Right. If the image can be taken onto the screen, that is real. if it cannot be taken onto the screen, it is virtual, right? That's the thing. Now, in last day, we discussed about images through prisms. All of them were real, right? Now you can understand it better if you go back and see, because all the images that form through a prism, keeping a screen is possible, right? You can keep a screen without blocking light rays, right? So that's why all of them were real images. That's why all of them were real images. All images due to prisms are real. All the images are real, right? Okay. As the next heading, write down significant rays. Significant rays. Next heading, significant rays for a convex lens. Significant rays for a convex lens. Significant rays for a convex lens. First one. Significant rays for a convex lens. Look at here. First one. Okay, this is a convex lens, right? This is a convex lens, and this is the principal axis, right? First ray is about the parallel rays. First diagram is about the parallel rays. Look at here. If a beam of parallel rays, if a beam of parallel light falls onto the convex lens, right? You already know now what is going to happen is all of them are going to be converged to a same point on the principal axis. That same point is called what? The focal point, right? F. Take this down, right? This is focal point. I have already labeled before. Same thing, focal point. Focal point. Significant rays. What's the subtopic? Significant rays for a convex lens. Significant rays for a convex lens. Right. Second one. See, now tell me, what was alternative property of light? We discussed in from the very beginning of light. What was the alternative property of light? What is meant by alternative property of light? In simple words, tell me. What about online students? You didn't respond for anything today. Respond now. Right? What is alternative property of light? Just tell me the idea. We have been discussing about alternative property of light for like 3 weeks, 4 weeks of time now. What is it? One's on YouTube, Zoom, anyone. So you can respond. I can see both chat boxes here. What do you say? Alternative property of light. Quickly. What is alternative property of light? පේනවනේ සතියයි ක්ලාස් තිබ්බේ නැත්තේ. කොහොම තමයි ඇත්තම කියන්නේ. මේ A level subjects වල තියෙන විදිය ඕකම තමයි. Right? If you stop going through these things, let's say for a month, 4 weeks, ආයෙ ඕක recover කරන්න බෑ. එහෙම තමයි හැදෙන්නේ. එහෙම තමයි හැදෙන්නේ. Right? Like මේ weeks වල මේ I mean in past 2 weeks, right? The mentality was not that educational related, no. එහෙම තමයි. ඕන කෙනෙක්ට එහෙමයි. As citizens in Sri Lanka, right? What you are seeing in social media, if you log into social media, is all about the disaster. Maybe dead bodies, right? Or abandoned houses, damaged houses, right? අර ඔක්කොම තියෙන disaster එක ගැන. ඔක්කොම disaster එක. Facebook එකට ගියොත් තියෙන ඔක්කොම disaster ගැන. TikTok එකට ගියොත් ඔක්කොම disaster එක ගැන. Instagram එකේ ගියොත් disaster එක ගැන. News දැම්මොත් news වල it's all about the disaster. Right? ඊට පස්සේ තව මොනවා හරි. රේඩියෝ එක ඇහුවොත් it's about disaster. හැමතැනම ඒක ගැනනේ තියෙන්නේ. ඒතොර එහෙම වෙද්දි අර educational mentality එකෙන් ඔයා deviate වෙනවා. දන්නේ නැතුව. ඔයා හිතන්නේ නැහැ not something intentional but unintentionally you are getting deviated from that mentality. Right? එහෙම වෙනවා. But now it's gone. It's gone in the sense now we have to move on now. Right? You have to move on. Right? ටක්කල බලන්න ලියලා ඇත්තේ. Go back to the note and tell me. Note එක ලියලා තියෙනවා in red. Quickly. Online. Light traveling back the same path. Aisha. Anyone on YouTube? Regular class students ලා ඉන්නවා නම් YouTube එකේ කියන්න පුළුවන්. ලියපු තැන මතකත් නැහැ. තාම වෙනවා. Anyone else from online students? Zoom? Light traveling back at the same path. Hari, it's correct. Anyone else? Found it. Hari, මොකක්ද තියෙන්නේ? Yeah, that's a phenomenon of occurring the opposite direction of light rays if there is a given refraction, which means if something happens in optics in a particular way, which means it happens in the exact opposite way as well, the other way as well, vice versa. ඔන්න ඕක තමයි alternative property එක කියලා කියන්නේ. Right? එහෙනම් මම ඒක දැන් මෙතෙන්ට relate කරනවා මේ බා. If a parallel beam of light falls, it is converged through the focal point, no? Converged to the focal point, no? Then what happens if light rays are diverging out from the focal point? It should be parallel after refraction. If a light ray travels from here to here, the opposite light ray also travels. That's the alternative property of light. එහෙනම් මේක opposite එකක් වෙනවා. So therefore, if light rays are diverging out from the focal point like this, if light rays are diverging out from the focal point, make opposite එකනේ දැන් මේ තියෙන්නේ. If light rays travels this way, it travels the other way as well. Alternative property of light. Then it should be parallel, exactly parallel after the refraction. This is called alternative property of light. Right? Second diagram, alternative property of light. These two follows alternative property. These two follows alternative property. Right? Take down. And somewhere here within brackets you can mention that, right? Somewhere here within brackets you can mention that alternative property. Alternative property of light in 1 and 2, in diagrams 1 and 2, that is about alternative property of light in 1 and 2. That's the alternative property of light. Okay, next one. Next one. Look at the board. Right? The point on a lens where the horizontal and vertical symmetric lines are intersected is called what? You know these terms from O levels. This point is called optical center. Another. O levels. Principal axis, focal point, optical center. C optical center. Right? The point where symmetric lines of the lens are intersected is called the optical center. We denote it by C. See? C, the C here, we denote it by C. Right? That is called optical center. C is optical center. Optical center. C, optical center. Look at the board. Now, this is the thing. If any light ray goes through the optical center, right, it won't be refracted. If any light ray goes through the optical center, it won't be refracted. Because what happens is, if a light ray goes through optical center, which means there is going to be a perpendicular incidence here. Right? Circles again. There is going to be a perpendicular incidence. In a perpendicular incidence, there is no refraction. So therefore, if a light ray goes through optical center, if a light ray, any light ray goes through optical center, it won't be refracted. If a light ray goes through optical center, it won't be refracted. Right? So that's the only one type of light ray we have in a lens that is not refracted. All other light rays are refracted. Perpendicular incidence. Perpendicular incidence. Right? Circles and the right? Okay. Take it down. C is the optical center. Optical center. Keep them in mind, because that's the terminology we have here. That's the terminology we have here. We will be dealing with lenses in this week and the coming week, right? So throughout we will be learning all the terminology. After lenses, the next part we are going to start is defects of vision. Defects of vision, eye defects, right? There are only two more parts remaining from optics. Defects of vision, that's a small part, and optical instruments, that is also a small part. Last one. Look at here. This is what happens if an inclined parallel beam of light falls. This is what happens if an inclined parallel beam of light falls. I have explained I think one or two questions in the paper class, in the last paper, right? Oh, explained that, right? Focal plane එක ගැන කිව්ව මොකද මම එක paper class එක. දැන් මේ කතා කරලා මම කිව්වා. Focal plane ගැන කිව්වේ නෑ. Focal plane එක ගැන කිව්වා, right? If you were there on that particular day in the paper class, මම මේ focal plane එකෙන් questions දෙකක් discuss කරා. 2 MCQs. right? අන්න ඒක තමයි මේ තියෙන්නේ. මම කිව්වා මේක next week එකේ theory class එකේ කරනවා කියලා. මේ තමයි ඒක. See? If a parallel beam of light falls, මේක construction එකක් කරලා ගත්තේ. මම කිව්වා මේක construction එකක් කරලා intersection point එක ගන්න කියලා. කළා ඒක. right? See? This is a parallel beam of parallel inclined beam. See? Parallel beam of light, but that is inclined to the principal axis. Right? Now, this is also a parallel beam, but that is parallel to principal axis. This is a parallel beam, but inclined to principal axis. Right? So in such a case, this is what is going to happen. Let's say the focal point is here. We know if a parallel beam of light comes, it is converged at the focal point. No. Here what happens is, now you can get the exact point that is going to go using this ray, because this is the ray which goes through optical center. See, this is a ray, this one. This is the ray which goes through optical center. It should not be refracted, which means this ray is going to go like this without being refracted. It is going to go like this without being refracted, right? Now if I extend this, this ray is intersecting this line at this point now, right? So when this goes through this point, all other light rays are also going through the same point, right? Therefore, after the refraction, that is how that point is identified. This is the only ray that you can draw to identify that intersecting point. Then you can draw all other rays to the same point, right? කියන්නේ මේ point එක මොකක්ද කියලා එකපාර නිකන් හිතන්න බෑනේ. ඒකේ direction එක ගන්න මෙන්න මේකේ. මේ යන එක extend කරනවා. right? තාම මතක නැත්තම් last ඒ කියන්නේ paper 4 එකේ MCQ paper එක බලන්න. අන්න ඒ paper එකේ මේකෙන් questions දෙකක් තියෙනවා. ඒතර මතක් වෙයි. right? paper 4 එකේ මේ week එකට කලින් තිබ්බ paper එකේ. මේවත් මෙන්න මේක through යනවා. All these light rays are also going through a same point on this vertical line, like this. All of them goes through the same point on the vertical line like this, right? This vertical plane is called the focal plane, right? Focal point is here. Now that is not converging at the focal point now, but instead it converged on a point at the focal plane. Focal plane is the vertical plane which goes through focal point, right? This is the last one, right? There are only 4 significant ray diagrams for a convex lens. These are the all 4, right? Which means using these 4 diagrams, we are going to draw all the ray diagrams which are coming up in a convex lens, right? So මේ හතරේ තමයි මේ concept එක තියෙන්නේ. අපි images ඉස්සරහට හදනවා. We are going to form images using convex lenses. So when you are drawing the ray diagrams in convex lenses, right? These are the learnings that you are going to take out, right? If a parallel light ray comes, it goes through optical center. If a light ray comes through the optical center, it will be parallel after refraction, right? Optical center में focal point. If a light ray goes through the focal point, it will be parallel after refraction. And if any light ray goes through optical center, it won't be refracted. And if a parallel light ray or parallel light which is inclined to principal axis force, it is going to converge at a point on the focal plane. These are the 4 significant ray diagrams we have, right? Okay, complete. මේක මතක නැත්තම් මං කියන paper 4 එකේ question එක බලන්න. මම මේක next week එනවා කියලාම මේ question එක explain කරේ. ඉස්සරහට තියලා තිබ්බ එකකින් question එක දාලා තිබ්බේ. If you can't draw straight lines manually, you better use a ruler. Can light rays නිකන් අඳින්න එපා මේ. මෙහෙම හොදේ වැරදි. මෙහෙම නම් light rays අඳින්න එපා. Totally wrong. No marks. Light rays are straight, right? එහෙම නම් light rays අඳින්න එපා. ruler එක ගන්න නැත්නම් card එකක් තියලා හරි අඳින්න වෙනවා. Light rays are straight. මොකද දැන් ක්ලාස් එකක් කරන්නේ? ඈ recording එක බලන්න. right? ඒක නම් කොහොමත් ඒක ෆස්ට් ඩේ එකක් නේ මේකෙත් ඇති YouTube එකේ ඇති නැත්නම් සයිට් එකෙන් බලන්න කොහෙන් හරි රෙකෝඩින් එකක් බලන්න ක්ලාස් එක නෙමෙයි ක්ලාස් එකේ 30 minutes මිස් වුණත් ඒ පාර්ට් එක කවර් කරගන්න ඕනේ කියන්නේ දැන් එහෙම මිස් කරලා බෑ we are just 8 months ahead if there is in August right August වල plan කරමු දැන් A levels පොඩ්ඩක් postpone වෙච්ච නිසා there's a possibility listen there's a possibility of shifting your exam backwards by 2-3 weeks there's a possibility right but there is not officially announced no so therefore we will be planning to August right දැන් දන්නවනේ ICT දැන් අලුතෙන් shift වෙලා තියෙන්නේ කවද්ද ICT අලුතෙන් තියෙන්නේ 16th and January 16th and 18th January 16th and 18th January yeah I don't think but the thing is for the students who were doing ICT now the gap between physics second paper and the ICT first paper is 2 months more than 2 months right 2 months gap එකක් තියෙනවා අන්න එතකොට ළමයි පොඩ්ඩක් ඩිමෝටිවේට් වෙනවනේ that's the only issue it's true but they were about to finish their exam in another 2 days and all of a sudden it was now extended to 2 months අන්න එතකොට පොඩ්ඩක් එනවනේ මේක 2 days වලට ready වෙලා හිටපු කෙනෙක් now they were readying for the exam tomorrow and suddenly now the exam is on 16th of January that's the thing finished okay write down below with a red pen below the fourth one no? below fourth diagram write down below with a red pen an inclined parallel beam an inclined parallel beam of light an inclined parallel beam of light an inclined parallel beam of light converges at a point an inclined parallel beam of light converges at a point on focal plane converges at a point on focal plane next point keep using red focal plane is the vertical plane which goes through focal point right listen next thing now when we are dealing with light rays when light rays are traveled in different directions we have to have a standard to identify those directions no right now as an example you know vectors right vectors is the best example in vectors since we need to identify the directions of vectors right we have a signage right same directions are considered as positive opposite directions are considered as negative so something like that is there no with the signs here also that kind of a same kind of a standard is there right because otherwise how to identify a light ray travels in rightward direction and leftward direction there should be a way to segregate these two no distinguish between these two no so therefore there is something introduced to the world as sign convention in optics sign convention there is a convention what is a convention conventions දන්නවනේ conventions කියලා කියන්නේ මොනවද what are conventions I'm not asking the physics meaning what is the meaning of the word convention What's the meaning? Convention. Huh? Don't know. Convention කියලා කියන්නේ standard එකක් වගේ. ඒ වචනේ අහලා තියෙන්න ඕනේ. Convention means that's a standard. Standard. Convention means a standard. Right? Standard. Right? Okay. Write down sign convention in optics. Sign convention in optics. Sign convention in optics. Convention කියද්දි මතක් වුණේ convocation of University of Moradua is also coming up next week. Right? දැනගන්න කිව්වේ ඉතින් ඩිසෙම්බර් වෙද්දි තමයි සාමාන්‍ය convocation එකක් එන්නේ. Right? එතකොට ඉතින් ඕගොල්ලොත් University of Moradua ආවොත් එන future December එකක you will be graduated. Right? Now this is the convocation for 20th batch. Batch 20. Right? Batch 20. Batch 20 කියලා කියන්නේ there are 20 intake. तर first year එක කියන්නේ 2021. හරිනේ ගාන්ටි කරලා තියෙනවා 21 22 23 23 24 අනේ not the 20th batch I guess 20 21 22 23 24 yeah 20 4.5 years ගිහිලා මේ පාර yes 20 මේ 20th batch එක 20th batch එක කියලා කියන්නේ those are the ones who did A levels in 2019 no 20 right 20 වල A levels කරපු කට්ටිය තමයි මේ pass out වෙන්නේ right 20 වල A levels කරපු කට්ටිය තමයි pass out වෙන්නේ. ඒතර මේ මම දැනගන්න කිව්වේ next week next Thursday දවස් තුනක් තියෙනවා because there are 5 faculties there no medical yes medical was introduced to University of Moradua in 2017 or 18 මේ ළඟදී ආවේ that's the latest faculty we have the youngest faculty we have medicine කලින් medicine තිබ්බේ නැහැ අලුතෙන් faculties දෙකක් ආවා මේ business එකකුයි business faculty එකකුයි medicine එකකුයි business was introduced in 2017 medicine 18 medicine එක ඊට පස්සේ ආවේ ඒක 18 then medicine set score එක වැඩි මේ මොරටුවේ ඒ කියන්නේ even though that's a new one with the recognition for the university and the closeness to Colombo more students are applying for it so therefore set scores are going higher set score එක කියලා කියන්නේ apply කරන එකත් එක්කනේ ඒක වෙන්නේ set score varies with the set scores of the students who have applied for a certain degree right so දැන් ඒකට set score එක වැඩි කට්ටිය apply කරන්න ඒකේ set score එක rise වෙනවා it rises up right if the students of average set scores are applying then it rises down it falls down right so දැන් ගොඩක් උඩට හැවිලා තියෙන්නේ University of Moradua medicine set score එක first එකේ තියෙන්නේ මොකද්ද Colombo second or third Moradua ඇවිල්ලා තියෙන්නේ ඒ කියන්නේ even though that's a younger faculty එහෙම වෙනවා ජපුර engineering එකට එහෙම වුණා මතකද දන්නේ නැහැ ජපුර engineering was introduced in 2016 يعني first batch එකේ ඉන්නේ 2016 ඒක තමයි latest and the youngest engineering faculty we have so far in a state university ජපුර right ජපුර දාපු ගමන් රුහුණ වගේ ඒවට වඩා ජපුර 2 years යද්දි උඩට ආවා because of the closeness to the Colombo එතකොට ගොඩක් කට්ටිය රුහුණ කියන්නේ faculties in goal right goal දන්නවනේ හපුගල තියෙන්නේ goal හපුගල faculty එකට යන්න නැතුව ඒ කියන්නේ දැන් ගොඩක් වෙලාවට ඕක වෙන්නේ for the students who are especially living around western province and western province එකේ ඉන්න population එක වැඩි since the population is higher right they are reluctant to go to the outstation provinces so they try to stay close to Colombo so therefore they are applying for the closer ones එතකොට ජපුරට apply කරන්න ජපුර උඩට එනවා දැන් ජපුර රුහුණ පාස් කරලා තියෙන්නේ එහෙම වෙනවා ඒක natural right ඊට පස්සේ ආයෙ හැම set scores වැඩි වෙනවා unique degree එකක් ආවම as an example artificial intelligence in University of Moradua that's the only one degree in AI that we have in a state university right ඒකේ set score එක දැන් ගොඩක් වැඩි that's the only one no so more people are applying now it's varying around 1.8 1.9 right? 1.8 වගේ තමයි last time thing, right? set scores එකෙන් බලන්න නිකන් search කරලා, right? district wise බලන්න, if you are facing the exam from Colombo, see Colombo district quotas, Colombo district set scores, right? if you are from Kandy බලන්න, if you are from Madale බලන්න, අන්න ඒ වගේ තමයි වාගේ level එකෙන් බලන්න. Z score is a weighted average of all three subjects. ඒකට එන මාක් එහෙම නෙමෙයි calculate වෙන්නේ. නෑ ඒක එන්නේ standard deviations එහෙම කරලා තියෙනවනේ. standard deviation එකෙන් එන calculation එක. stats. මේ නතෝ mark එකට නෙමෙයි. calculation of Z score and GPA in university is two different things. GPA calculate කරන්න අර විදියට. ඔයා කියපු විදියට. Z score එක එහෙම නෙමෙයි. difference එකක් තියෙනවා. right? ඉතින් මම කිව්වේ ඒකයි. now our convocation is coming up, right? සමහර යාළුවෝ ඉන්නවා මට යන්න බැරි වෙයි. ඉතින් next Thursday තමයි පටන් ගන්නෙ. මේ ඉතින් අපේ department එකේ juniors ලා graduate වෙනවා. Thursday ඉතින් class දවසක්නේ. DMICH එකේ තියෙන. right? ගිහිල්ලා බලන්න. මේ ගිහිල්ලා බලන්න කියන්නේ class cut කරලා නෙමෙයි. මේ පුළුවන් වුණොත් එතනින් ගියොත් DMICH එක පැත්තේ නිකන් බලන්න මේ නිකන් ඒතකොට ආසයිතේ. ඒක මාර එකක්. There are only 2 days that you can take your parents into the university. Only 2 days in your university life. In University of Moratuwa, that's how it is. And in most of the other universities as well, right? Pera වගේ නම් සමහරලාට Pera campus එක මේ since it is open to Pera දෙනිය, since it is open to the Galaha road, it can be easily accessed through the Galaha road. But for other universities, you can't just go in without having a proper permission, ID, simply ID, university ID, right? So therefore there are only 2 days, right, that you can take your parents into a university. First day is the inauguration day, the very first day that you are going to the university. එතකොට parents ලා එක්කන් යන්න පුළුවන්, right? parents විතරක් නෙමෙයි ගමමුණත් එක්කන් යන්න පුළුවන් first day එකේ. ඇත්තටම කියන්නේ. right? ඒ කියන්නේ සමහර කට්ටිය එනවා මේ from remote areas, right? සමහරලාට ඒ මුළු village එකටම එයා විතරයි university select වෙලා තියෙන්නේ. ඒතකොට ඉතින් මුළු village එක පිටින් එනවා. එහෙම කට්ටිය ඉන්නවා. ඒ කියන්නේ that's the happiness they have. Right? When someone from their village goes for the university for the first time maybe. එහෙම තියනවද? It's very valuable. එහෙම තියනවා. මේ කොළඹ වගේ නෙමෙයි. එහෙම ගොඩාක් ඈත පැති වලින් එන කට්ටිය ඉන්නවා. ඒතර first day ඕන කෙනෙක්ට එන්න පුළුවන්. For the inauguration program. Right? And last day is the graduation day. ඔය දෙකේ විතරයි යුනිවර්සිටි එක ඇතුළට එන්න පුළුවන් parent. For parents. right? නැතුව එන්න බෑ. ඔයාව බලලා යන්න කියලා නිකන් ඇතුළට එන්න බෑ. එහෙම වුණොත් ඔයාලට ගේට් එක ගාවට ගිහින් තමයි කතා කරන්නේ. ඇතුළට ගන්න බෑ. එහෙම තමයි ඒක. right? So therefore just know those things and have a dedication that someday you are going to take your parents in to the university and someday you are going to going to graduate in front of them, right? So O levels A levels වගේ නෙමෙයි graduation එක කියලා කියන්නේ that is the first main what we call the achievement that you are going to get in your lifetime for the first time. BSc එක bachelor's degree කියලා කියන්නේ your first achievement, a proper achievement in your life, right? Probably that's the day that your parents will be mostly happy about yourself, right? For everything that they have dedicated for 24 years. 20 නෙමෙයි අතරම 20, around 24 years by the age that you are graduating, right? කොහොම හරි ඒගොල්ලන්ව ඒකට අරගෙන යන්න. සමහර කට්ටිය ඇවිල්ලා අඬනවා. ඉතින් එහෙම තමයි. ඒක තමයි සතුටට. අඬන්නේ දුකට නෙමෙයි සතුටට. එහෙම තමයි. graduation එකේ ඕන තරම් අඬනවා. ඕන තරම් අඬනවා. තර සමහරලාට ඒක දැක්කට පස්සේ ළමයිත් අඬනවා. එහෙම තමයි. මේ ඊට පස්සේ BSc එකෙන් පස්සේ MSc PhD මොනවා කරත් අර ෆස්ට් එකට තියෙන BSc එකෙන් BSc එකේ තමයි වැඩිම ඉමෝෂනල්. එහෙම තමයි හැටි. right? so හින්දා කොහොම හරි BSc එක අරගෙන doesn't matter from which university you are passing out, take your bachelor's degree from the university, from any recognized university, recognized state university, yeah? Recognize means recognize state university. Right? Free education එකේ ඒ තියෙන advantage එක ගන්න. ඒතොර ඉතින් ඒක නියමයි. Right? The opportunities that you are going to open up are immense. ආයේ ඒක සල්ලි වලට ගන්න බෑ. ඒක immense. ඒ feelings කොහොමද සල්ලි වලට ගන්න බෑ. Right? එහෙම තමයි. ඒක මාර එකක් මේ මට ඉතින් ෂෙයා කරගන්න මතක් වුණේ next week graduation එක එනවා. අපේ convocation එක University of Moratuwa. මේ ජපුර එක මීට අපිට කලින් තිබ්බා. ජපුර එක මතකද දැක්කද දන්න? අර්මාන්සස්. Yes. ජපුර එක තිබ්බා. Arman's graduation එක තිබ්බා. My sister was also there. So I was there because my sister was there. Japura was before I think 1.5 months to 2 months වගේ. ජපුර එක තිබ්බා. දැන් University of Moratuwa ඩිසෙම්බර් වල තමයි ගොඩක් ඒවා එන්නේ. Colombo is also coming up. අනිත් ඔක්කොම ටික ඩිසෙම්බර් වල තියෙයි. Right? රජරට, ඌවවෙල්ලස්ස, සබරගමුව, right? Eastern, right? Everything is coming up. මුලින්ම තියෙන්නේ ඔය ඩිසෙම්බර් තියෙන සෙට් එකෙන් මොරටුව එක. ඒක තමයි දැන් ඩිසෙම්බර් next week 17th. 17th තමයි start කරන්නේ. 17th, 18th, 19th මං හිතන්නේ තියෙන්නේ. කොහමද? දවස් 3ක් තියෙනවා අපේ graduation එක. right, okay. හරි මම මේක ෂෙයා කරගත්තේ පොඩි වෙලාවක් අරගෙන මේ you should be there one day. Right? That's why you should be there one day. මම මේකම කිව්වා මේ මම එදා ජපුර graduation එකට ගිහින් ආවේ Friday එක. ඒතකොට Friday මම කෙලින්ම ආවේ මේ 27 batch එකේ class එකට. ඒතකොට මම මේ formal නේ ඇඳලා හිටියේ. ඒතකොට ඉතින් කට්ටිය ආවට පස්සේ මම කිව්වා මම කොහෙද ගියේ කියලා. formal ඇඳගෙන හිටපු නිසා. graduation එකට නේ ගියේ. මේ casual මෙහෙම නෙමෙයි ආවේ. class එක විදියට නෙමෙයි ආවේ. මේ ඒතකොට මම ඒගොල්ලෝ එක්කත් ඒක share කරගත්තා මේ ඉතින් එහෙම තමයි. right? ඒතකොට University of Moratuwa graduation කියලා කියන්නේ ඒක මාර level එකක්. එහෙම තමයි ඉතින්. right? Best engineering students are there. right? medicine උත් එහෙමයි. medicine ඒවත් එහෙමයි. අනිත් Moratuwa විතරක් නෙමෙයි in any state university any degree is invaluable. ඒක ආයි සල්ලි වලට ගන්න බෑ. right? ඉතින් give that happiness to your parents one day. ඒක තමයි වෙන්න ඕනේ. right? So then up until you are being graduated, all the things about you, I mean taken care, looking after you and taking care of you is done by the parents, no? Right? එහෙමනේ usually වෙන්නේ until you are graduate වෙනකන් ගොඩක් වෙලාවට කෙනෙක් job එකක් කරන්නේ නැහැ නේ. right? So if you don't have a job, you don't have an income, no? So therefore you are dependent on the family. So therefore all the things will be taken care by the family itself. right? By your family itself. අම්මයි තාත්තයි ඔක්කොම කරන්නේ. ගෙදරට අපි සමහරලාවට graduate වෙනකන් right? වෙන මොකුත් වල income source එකක් නැත්තම් සමහර කට්ටිය පොඩි දේවල් කරනවා part time. එහෙම මොකක් කරේ නැත්තම් you are totally dependent on the family. ඒතකොට එතනින් පස්සේ තමයි ඔයා job එකක් කරන්න start කරන්නේ. ඉතින් ඒක ලොකු turning point එකක්. එහෙනම් ඉතින් ඒක හරිම emotional මාර අමුතු එකක්. That is a once in a lifetime feeling that you can get. Guaranteed. BSc එක කරලා ඔයා ඊට පස්සේ MSc එකක් master එකක් කරා කියලා අර BSc එකේ feeling එක එන්නේ නැහැ. second එකනේ. second degree එකනේ වාගේ first degree එක වගේ එක feel වෙන්නේ නැහැ. එහෙම තමයි. right? that's why PhD එකක් කරොත් as a qualification that is way far higher than a BSc. හැබැයි වාගේ third graduation එකනේ. ඒකට අර first එක තරම් feel වෙන්නේ නැහැ. එහෙම තමයි හැටි. වෙනවා. okay. ඒද මේ මම next week කියන්නම්. ඉතින් මේ next week තමයි graduation එක තියෙන්නේ. right? තර ඕල්ලොත් දවසක අන්නේ විදිහට graduate වෙන්න ඕනේ. ඒකට තමයි මම මේක share කරේ. ගොඩක් campus වල graduations තියෙන BMICH එකේ in some universities that they have enough facilities inside the university, they are taking the convocations in the university itself. As examples, University of Peradeniya and Rajarata. ඔන්න ඔය දෙක තමයි mainly inside university graduations ගන්න because they have enough space there. right? දැන් University of Moratuwa වුණත් ලොකු එකක් වුණත් අපේ space මදි for all the students and their parents. ඒ හින්දා තමයි BMICH එක ගන්න. right? okay, that's enough. Sign convention in optics. okay, listen. Sign convention කියලා කියන්නේ මෙහෙමයි. Sign convention in optics. Sign convention කියලා කියන්නේ these are standard. These are rule standard we have when dealing with optics. right? First thing is all the distances are measured from optical center only. All the distances measured are from optical center only. What is optical center? C, right? Optical center only. That's the first thing, right? Second thing about sign convention is all the distances measured to the same direction of light are considered as minus, and opposite direction of light are considered as plus, right? Vectors වගේම තමයි plus minus signage එකක් මේ තියෙන්නේ. sign convention එකක් තියෙන්නේ. All the distances are measured from optical center, right? කොහෙට measure කරත් මනින්න optical center එකේ. හරියට simple harmonic motion එකේ වගේ. In simple harmonic motion all distances are measured from center. Okay? Displacement are measured from center. Wherever the particle is, wherever the object is, displacement is measured from center only. ඒ වගේම තමයි. Here all the distances are measured from optical center only. Distances measured to the same direction of light are minus and opposite direction are plus. Same එක ඉන්නේ minus මේක මාරු වෙලා තියෙන්නේ. පටල ගන්න එපා. Same is minus. Right? Write in red. Write down in red. There are two parts in sign convention. Write down in red. Part 1. Part 1. All distances. Write down. All distances. All distances are measured from. All distances are measured from. All distances are measured from optical center only. All distances are measured from optical center only. Right? All distances are measured from optical center only. Part 2, second one, number 2 කියලා දාලා යන. Part 2. Write down. Distances measured along the same direction of light rays. Distances measured along the same direction of light rays. Distances measured along the same direction of light rays. Distances measured along the same direction of light rays are considered as minus, negative, minus, and distances measured along the opposite direction, and distances measured along the opposite direction, and distances measured along the opposite direction, distances measured along the opposite direction of light rays are considered as plus. See, I'll do an example here. Say, now this is a convex lens. This is a convex lens, right? And for this convex lens, light rays are falling from this side, like this. Right. Now, what is the direction of light rays? Rightwards or leftwards? Rightwards. Right? Which means all distances measured to the rightward direction. So we know distances are measured from optical center only. Optical center is here, right? So this line is considered as the line which goes to optical center. So all distances measured to the direction of light is considered as minus, right? All distances measured to the opposite direction of light is considered as plus, right? Now, as an example, this is the focal point of this, no? Then, if you are measuring the focal length from optical center to focal point is called focal length. Focal length, right? Focal length is measured from here to here, like this. Here to here, like this. This is called the focal length. This is called the focal length, right? This is called the focal length. Now, in this case, focal length is measured to which direction? Same direction of light rays. Therefore, this is called a negative focal length. Negative. This is minus. Therefore, focal length or the focal point of a convex lens is minus. Right? How many focal points for a given lens? How many focal points are for a given lens in total? Tell me. How many focal points for a given lens? Quickly. Common sense. How many focal points? How many focal points in total? Active wave තියෙන්නත් පුළුවන්, inactive wave තියෙන්නත් පුළුවන්. How many focal points? 2. There are 2 focal points. Right? Only one is active at a time. Right? Light rays මේ පැත්තෙන් આવොත් මේ පැත්තේ focal point එක active. What the point? When light rays are falling from this side, this focal point is active now. Active. It's working now. If light rays are falling from the other side, right, without changing the lens, then the opposite focal point is going to active. So therefore, there are 2 focal points in total, but only one focal point is active at a given time. Got it? So therefore, always active focal point of a convex lens is going to be minus. Again, sign convention again. Right? That is given, no? That is given. Focal length of a convex lens is negative. Right? අපි concave එකකට බලමු. Focal length of a concave lens is going to be positive. එහෙම වෙනවා. Right? Take this down. This is the example. You can raise if any questions. So adding something to the last thing I told you about the convocation. Seeing tears of your parents in your life is kind of a rare incidence. Right? එහෙම හැමදාම වෙන්නේ නැහැ. එහෙම තමයි හැටි. එහෙම අම්මලා අඬන දවස්, අම්මලා තාත්තලා අඬන දවස් යන අඩුයි. හරිද? ඒතකොට ඒවා හරි වෙන valuable points. නාර valuable points. ගොඩක් වෙලාවට convocations වල එහෙම වෙනවා. හරි. දැන් convocation එකට කලින් සමහර වෙලට වෙන්න පුළුවන් A level results ආවා. ඇත්තම වෙනවා. එහෙම තමයි ඔතේ. අරගෙන බලන්න මම මේ කියන්නේ බොරුද කියලා. දැන් A level results ආවිල්ලා හිතන්නෝ 3 years වගේ වාරගෙන මොකක් හරි rank එකක් අරගෙන you have selected to some university. right? අන්න එහෙම වෙද්දී ඒගොල්ලන් මාර සතුටු වෙයි. ඉතින් සතුටට ඇඬෙනවා. එහෙම තමයි. එහෙම දවස් හරි අඩුයි and those days are the most valuable days in our lives. right? නිකන් අම්මලත් එක්ක කතා කරලා අහලා බලන්න දවස් මොනවද අඬලා තියෙන්නේ කියලා. දැන් මේ වෙනකන් අරපු දවස් දෙක තුනක් ඇති සමහර විට. O level results වලට සමහරට එහෙම වෙන්න පුළුවන් සමහර කට්ටියට. A levels වලට එහෙම වෙන්න පුළුවන්. right? ඊට පස්සේ සමහර විට now if you are going to a distant university and if you are going to go to the university, I mean if you are going to stay in a hostel or somewhere for the first time outside home, අන්න ඒ වගේ වෙද්දී සමහරලාට අඬනවා. ඊට පස්සේ convocations වල ගොඩක් ඒක වෙනවා. right? ඒක මාර milestone එකක් නේ, turning point එකක් නේ. ඊට පස්සේ ඉතින් girls ලගේ වගේ නම් on the day of marriage එහෙම වෙනවා. ඉතින් එහෙම days හරි අඩුයි. 5ක් 6ක් දෙයි ඕනනම් for the entire life. හැමදාම එහෙම වෙන්නේ නැහැ. කියන්නේ දැන් ඔයාගේ BSc එකේ අම්මලා ඇඬුවා කියලා ආයෙ MSc එකේ අඬන්නේ නැහැ උඩක් කියලා. කියන්නේ second එක වෙද්දි එහෙම තමයි. first එකේ තමයි අර මේක තියෙන්නේ. first එකේ තමයි කොහොමද තියෙන්නේ. right? So therefore it's more valuable. මං කියන්නේ මේ අඬවන්න කියලා නෙමෙයි මං කියන්නේ it's valuable. It's more valuable. අඬන්නේ සතුටටනේ. right? There are tears for happiness, tears of happiness. Okay, finish? Write down below first point. Write down below first point. Normal color with an asterisk mark. Write down focal point of a convex lens is real and negative minus. Focal point of a convex lens is real and negative. Focal point of a convex lens is real and negative. Right. So draw a concave lens here. See, now here this focal point is active, but light rays travels in the rightward direction. See, they are traveling in the rightward direction. So these are minus, these are plus. Now, if you measure the focal length, see, if you measure the focal length, that is measured from here to here, focal length. So this is a positive direction. Therefore, focal length of a concave lens is always positive. Focal length of a concave lens is always positive, right? Always the active focal point of the concave lens is here, behind the lens. Active focal point of a convex lens is in front of the lens, right? Again, තමයි direction again. Got it? The light rays පැත්ත මාරුනොත් ගානට sign convention එකත් මාරු වෙනවා, because sign convention depends on the direction of light, no? It depends on the direction of light. Take this down. And some of you were checking on me during the flood period as well, right? Some of you were checking. Thanks for asking. For our area, it was not that severe, right? So, you know, I'm from Orono. Orono means that is in Kaludara district. So, for Kaludara district, all around, it was not that severe. The reason is the river Kalu doesn't get that much of rainfall, even though river Kalani and river Mahavali got the more than enough rainfall, right? That's why it was not that severe for Kaludara district, right? In Mahavali and Kalani, those water capacities were more than 3 times of the average, right? More than 3 times of the average. Usual heavy rainfall is around 150 millimeters, right? 150 millimeters millimeters වගේ තමයි, I mean beyond, above 150 millimeters rain is considered as heavy rain. තොර දැන් අපි ඔය හයියෙන් වහින වැස්ස දකින්නේ ඒක 150 වගේ තමයි, right? අර storm එකේ it went up until 540 millimeters. 540, more than 3 times, right? ඒ වැඩිම rainfall එක තිබ්බේ මාතලේට. අෆීල් දන්නවද? මාතලේ ගම්මඩුව division in මාතලේ 540 කියලා කියන්නේ හිතා ගන්න බැරි තරම් ලොකු rainfall එකක්. අර වික්ටෝරියා වලත් maximum capacity එක ගාවටම ආවා. වික්ටෝරියා dam එක. What's the long term? I don't know. Show me again, then I'll check. මම ඒකෙන් බැලුවේ අර gauges විතරයි. Gauges බැලුවද? Gauges check කරා? Gauges තාම real time ඕන බලන්න ඕන. Okay, finish. Write down below. හරි මට පෙන්නන්න. Write down below. Focal point of a concave lens. Focal point of a concave lens. Focal point of a concave lens. Okay, real or virtual? Real or virtual? Concave lens? Virtual and plus. Focal point of a concave lens is virtual and plus, positive. That is positive, plus. Right. Next heading, not the heading actually. Write this down as a note. Take this down as a note. Note. And under this note, write down magnification. Magnification within brackets, linear magnification. Linear magnification. Right. See? Now, this is also a definition. No? Definition in the sense, it is something introduced, a standard equation introduced to write the magnification, to get the magnification or compare the magnification between the object and the image, right? For the comparison purpose, right? These are the equations. Look at here. Linear magnification is denoted by simple m. Simple m. That is called simple m, right? Simple m. There are three equations, basically three basic equations for magnification, linear magnification, right? One is image distance. Image distance. This is called V in optics over object distance. You will see these distances in the coming diagrams. Object distance is called U, right? These are the standard notations in optics. V and U are standard notations, not the velocities, right? Initial velocity, final velocity, right? The revision the V linear motion, right? Then image height over object height. You can take down along with me. Image height, capital H, object height, simple h. And image width, capital D, over object width, simple d. These are the three basic equations we have, three general main equations we have about the linear magnification in optics, right? These are the three equations we have. You have to know all three, right? For some context, only one will be applicable. For some context, maybe two equations out of these three are applicable. For some, all three are applicable, right? Thickness එකක් නැති objects එහෙම තියෙනවා. Linear objects basically. දැන් අපි අඳින්න තියෙන linear objects. For them, they don't have a thickness. If they don't have a thickness, there's no width. Right? Width එකක් නැති images තියෙනවා. Very thin images. So ඒවට මේක නැහැ. ඉතුරු දෙක තියෙනවා. Likewise, you have to know all three to use it wherever it's possible. Right? Okay, now write down the next heading. This is a next main heading. Write down formation of images of linear objects. Formation of images of linear objects by convex lenses. Formation of images of linear objects by convex lenses. Formation of images of linear objects by convex lenses. Formation of images of linear objects by convex lenses. Right. Finished? Listen. Now, this is the main part here about the ray diagrams in convex lenses. Right? මේ වගේම part එකක් that is going to come for concave lenses as well. Right? Okay. We are going to change the locations where the object is placed on the principal axis and going to get the images, respective images, based on the object, based on the location of the object. Right? OLEDs වලත් මේක සමහරට කරලා ඇති. Mirrors වලටත් ඔක OLEDs වල සමහරට කරලා ඇති. Right? දැන් මේ ඔක්කොම ටික ආයෙ මුලින්ම මතක් කරගන්න ඕනේ. Okay. And you know how to draw linear objects. We dealt with linear objects in prisms as well. How to draw a linear object? Using an arrow. Okay? අපි arrows වලින් යන්නේ objects in prisms. Prism වල එළියන්නේ? Yeah. කාබයිට් කාලා වගේ වලා ඉන්නේ prisms වල. Prisms වල එළියන්නේ? In prisms, we denoted images by arrows. And arrow is the graphical representation of a linear object. Linear objects means those are the objects without any thickness. Right? Okay. Right here. Now, one by one, we are going to discuss. As Rome number 1 write down, when object is kept beyond 2f, when object is kept like this, when object is kept, write down with me, beyond 2f, right? Simple f. Standard notation of focal length is simple f. Standard notation is simple f, not the capital F. right? Okay, when the object is kept beyond 2f, right? This is how we do. See, so I'll do the first one for you. Only the first one. See, draw the principal axis. Draw the principal axis, right? And draw the lens. When we are drawing ray diagrams, you can always consider this vertical line which goes through the lens as the lens. Which means, even though you have drawn the lens smaller like this, right? You can always consider this entire vertical line as the lens. That is a freedom you have been given, right? දැන් ඔයාට මෙතනින් ray එකක් අඳින්න ඕන නම් lens එක ආයි enlarge කරන්න ඕනේ නැහැ. Got the point? Always you can consider this line as the lens. ඒතොර lens එක ලොකුවට අඳින්න එපා මෙහෙම. පොඩි lens එක ඇතුළේ line එක අඳින්නේ ඇති. right? නැත්නම් lens එක පිටු භාගයක් විතර අඳින්න එපා වගේ. එහෙම extend කරගන්න ඕනොත් extend the line. That's a freedom given. For your convenience, right? Okay, and listen. You have to mark the focal point and 2 times the focal point on the principal axis, and they should be exactly f and 2f in terms of length, right? Measure කරලා අඳින්න ඔයා use කරන්නේ square ruled book එකක් නෙවෙයි නං, right? Square ruled book එකක් නම් count කරලා අඳින්න පුළුවන්. Otherwise you have to measure. Say you are taking 4 centimeters for the focal point, then at 8 centimeters 2 times focal point, f and 2f, right? And mark the same on the other side as well. Got the point? මෙන්න මේ ටික තමයි අපි mark කරන්නේ. And mark C here optical center. මෙන්න මේ ටික mark කරගන්න ඕනේ. Got the point? Clear now? Then we are going to do this. When object is kept beyond 2f, now my 2f is here. Keep the object beyond 2f like this. See, look at the board. Keep an object like this beyond 2f, right? Linear objects are represented, graphically represented using arrows. This is called the what? This is called the what of the arrow? This is called head of the arrow. Head. මේකට කියන්නේ head. මේකට කියන්නේ tail. Prisms වල මම කිව්වා. ලියලා නම් නැතුව head and tail. Head and tail. ඔතනින් තමයි බලාගන්නේ whether the image is going to be inverted or upright. මොකද්ද වෙන්නේ කියලා. මේක තමයි head එක. Like this, head and tail. Head and tail. මේක මේ invert වුණොත් head එක පල්ලෙහාට එයි. එහෙම තමයි බලන්නේ. Got the point? Okay. Now tell me, what's the minimum number of rays we need to locate an image? I asked the same question in prisms as well. 2. That's 2, right? Then using the significant rays, these are the 2 rays I'm going to use. Look at here. If I use a parallel ray to principal axis, it should go through focal point. It should go through the focal point after refraction, right? And as a second ray, I'm going to use a ray which goes through optical center. A ray which goes through optical center is, what's happening? Not refracted. Not refracted. So if you draw the ray which goes through optical center, see, if you draw the ray which goes through optical center, it is not refracted. And at the point where these 2 light rays are intersected, the image is going to be formed. Got the point? Now I have considered both light rays from the head, which means this is the point where the head is coming now. Got the point? Head again light rays out, form when head එක. Right? මගෙන් එන light rays වලින් ඔයාලට මගේ image එක form වෙනවා. ඒ වගේ තමයි head එකෙන් light rays වලින් the image of the head will be formed. So therefore these 2 light rays came from the head. So head is here now. Head is here. If the head is here, tail should be here. Right? Tail එක light ray එකක් අඳින්න නැත්තේ මේක principal axis එකේනේ තියෙන්නේ. Because if a light ray comes through the principal axis, it doesn't refract. This means tail is still on the principal axis. Got the point? ඒ ඉඳලා ඒක අඳින්න ඕනේ නැහැ. නැත්නම් ඒක අඳින්න පුළුවන් මේ. Tail එකෙන් light ray එකක් මේක අඳුනොත් it is on the principal axis now. Since it goes through optical center. So therefore tail is on the principal axis. So this is the image. We call this O. What is O? Object. Right? We call this I, image. Right? So hereafter you are going to apply sign convention. Listen, මෙතනින් පස්සේ මම කරන්නේ තව diagrams. path, you are going to apply sign convention, right? Rays distances which are measured to the same direction of light are considered as minus, to the opposite direction considered as plus. So this is what we call applying sign convention. You have to mention this. You have to mention this. That is what we call as applying sign convention, right? And then distance from, all distances are measured from optical center. No? Distance from optical center to object is called object distance, U. This is called U. Distance from optical center to image is called V, image distance, right? Mama kali magnification ke mention kare as V and U, these two, right? And now you have to write the sign convention or the signs of these ones as well. See, U, tell me, what's the sign of U? What's the sign of U? U is measured from optical center to here. You want it? This is the sign convention. Sign convention means all distances are measured from optical center only. Right? එහෙනම් මේක measure කරන්න ඕනේ මෙතන ඉඳන් මෙතනට. That is the positive direction. So therefore U is positive. Very easy. U is positive. What about V? V should be measured from optical center to this point along the negative direction. V is minus. What about focal length? Focal length is from, what is the active focal point here now? The left one or the right one? What is active now? What is active? What is active? Active. Right, only right. Make inactive. Active one is at the front in a convex lens, right? Make them active. The focal point again active, right? That is measured from optical center to here. That is also minus. Focal length of a convex lens is negative here. Got it? And then you have to write features of this image. It was all unknown features. Features of image. We are writing main four features. Four main features. Right? First thing is whether it's upright or inverted. What can you say? Upright or inverted? Upright means no inversion, not inverted. Upright can killing maybe no. Now it's inverted. Invert means harana. Inversion kine danna ne? Danna ne? Inverted means it is going to turn around. Inversion. Right? Now it's turned around. Ne? Calling negative head good than head palla. Right? Inverted. When may features unload. Inverted. Right? And second one is about the magnification. About the magnification real the virtual. What can you say? Whether it's real or virtual? Check whether a screen can be placed here without harming the incoming light rays. If I place a screen here, would it harm these incoming light rays? Would it block the incoming light rays? No. Which means this can be taken onto the screen. So that is real. That is real. Real image. Then magnification. We mentioned magnification as simple lem. Simple lem. Magnification. Now go to the equations of magnification. Height එකෙන් බලන්නත් පුළුවන්, distance එකෙන් බලන්නත් පුළුවන්. Magnification is image distance over object distance. V over U. What is greater? U over V. U is greater. Beyond 2F. This is between F and 2F. පේනවනේ? දැන් මේවා measure කරලා ඇඳ නැත්නම් එහෙම හරි තැන් වල location මේ හරි location එකට එන්න image එක හොඳේ. ඊට පස්සේ මග අඳින්න වෙනවා එපා වෙනකම්. ඒ හින්දා මේ rule එක අරගෙන if you are not using square rule books, right? Measure these ones and draw it. නැත්නම් හරියට එන්නේ නැහැ. For sure. එනික හිතලා අඳින්න එපා මේක නිකන් මෙහෙ අඳිනවා මේක හිතනකොට මෙහෙන් අඳිනවා එහෙම බෑ. දොරෙන්නේ නැහැ image එක. Right? මේ images හරිම තැනට එන්න ඕනේ. නැත්නම් image එක සමහරලාට මොනවාද enlarge වෙන්න ඕනේ image එක ඔයාලට නිකන් same size වගේ වෙයි. Because of the errors you have making lens. Right? ගන්න අඳින්න ඕනේ. Check the magnification. Look at the board. Check the magnification. You can either use image distance over object distance, right? Or image height over object height. Height. This is diminished. Height is decreased. Diminished. So therefore, magnification is less than 1. Magnification equals 1 means image distance and object distance are equal. Magnification equals 1 means image height and object height are equal, same in size. If there is less than 1 means there is diminished. And last is the location. What's the location of the image now? Between f and 2f. Between f and 2f. Between f and 2f. So likewise, these are the 4 features you are going to write for each and every image that you are going to get from the convex lens now. Right? Here onwards, I'll be giving you the point that we are going to keep the object. Right? You have to draw the diagram. Got it? Okay. Take it down. ලස්සන අදින්න ඕනේ. I didn't use any rulers. මම measure කරත් නැහැ. උනට මම ගන්න ඇදලා තියෙනවනේ. ඒ වගේ අදින්න ඕනේ. නැත් ෂුවර් නැත්තම් measure කරන්න rulers use කරන්න අදින්න. නැත්තම් හරියට image එක එන්නේ නැහැ. Okay, any questions so far? I mean, while taking down, tell me. Any questions so far? All good? Online? Online? What about online? Afil, Aida, Aisha, who else? Hamza, Ranuti, Taspida. Why is the participation is less today? All good? Ones on YouTube? What about the ones on YouTube? Is it all clear up to here? I hope all clear. If any questions, you can raise. My ray diagrams ලස්සනට අදින්න ඕනේ, especially the online ones because I can't see your books, right? Be very clear with the diagrams. Ah, is it 6:10 now? Okay, don't you have to pray? Online students? Praying time එක පහුණාද දන්නේ? හරි. And listen, it's a must to put arrowhead. If the arrowhead is not put, that is not a light ray, that is a straight line. That is called a straight line if the arrowhead is not put. So putting the arrowhead is compulsory. Putting the arrowhead is compulsory. All good, okay. Right? Finished everything? Right, so before giving the break, I'll give you the next instance. Then during the break also, or if you come to the class, before I'm coming to the class, you can try it out now, right? Second one. Write down the second one. Second instance. When object is kept at 2f. Second one. When object is kept at 2f. At 2f. When object is kept at 2f. When object is kept at 2f. When object is kept at 2f. You have to do all the things that we did here for this one. Huh? You have to do all the things that we did here for this one. Right. So actually I didn't notice that it is 10 minutes past 6 now. Right. So I'm sorry if your praying time is past already. Right. So in such a day, please inform. Right. If something like that happens. 27 එකේ එහෙම මාරවාදයක් තියෙන 27 එකේ පහ මාරේ ඉඳන් මට මතක් කරනවා 5:30 ද ඉලාම්ස් තියාගෙන ඉන්න කට්ටියක් තියෙනවා මොකක් හරි ඇප් එකකද කොහෙද මොකක් හරි එනවා ඉලාම්යක් ඉලාම්යක් වදිනවා 5:30 ඉඳන් so have to pray right okay We'll take the break. It's 6:10 now. Come back in 15 minutes, right? 15 minutes. Try this. Try this. Go have something and refresh yourself. And if you are praying, pray and come back. And we'll be taking the break from 6:10 to 6:10 to 6:25. Right. Sorry? Don't know. Look, I think the key is here. Okay. Right. What about this one? At 2f. Where did you get the image? At 2f. What's the magnification? Half? No. Huh? No, it should be 1. It should be 1, exactly 1. If your diagram is correct with all lens measurements, it should be exactly 1. Right? Because if the object is at 2f, image is also at 2f, 2f over 2f, lengths are same, magnification is 1. So heights are going to be same. Huh? You got the image. Object is at 2f, no? At 2f, right? Then V is up until here. Image is this. Sorry, red item. Image is here. So image distance is from optical center to image. Right? 2f or 2f1. मेरे को measure करो 1 के लेना. So I will again. It's 1. Yeah, it's correct. See? Check your diagrams. Right? F and 2f. F and 2f. Now, image is object is kept at 2f like this. Kept at 2f. Optical center is here. Parallel ray should go through the focal point. Parallel ray should go through the focal point. And this one should not be refracted, and it should go through the optical center. Right? So if your diagram is correct, now in my one there's a small mistake. Let me correct. This should go through this exact point, right? So the head has come here. Head has come here. Right? Head has come here. Now, object is at this point, image is at this point. Check all these things again. Now, you are doing the same thing again and again. Right? Distance from here to here should be u. Distance from here to the object should be v, and apply sign convention minus and plus, right? So still u is plus, v is minus, and f is minus. Active focal point is this one, right? And features, check your things, right? First one, inverted, no? Inverted, right? Real or virtual, screen can be kept real. And if you measure the magnification, right? Image distance and object distance are now same. Magnification equals 1. If you measure heights also, height should be same, right? So therefore, magnification is 1. What is the meaning? Here within brackets, first come here. Here within brackets, write down diminished. M less than 1 within brackets, diminished. Magnification less than 1, diminished. Right here. Magnification equals 1, no? What's the meaning? Equal in size, same in size, right? Equal size, same size. same size, equal in size, same in size, right? What about the location? Like this. What's the location? At 2f, right? Image is at 2f. Image is at 2f, exactly at 2f, right? Third scenario, when the object is kept between f and 2f, when the object is kept between f and 2f. Third scenario, kept between f and 2f, right? Right. When the object is kept between f and 2f. Quickly. When the object is kept between f and 2f. Now my plan today is to cover all theory parts of convex lenses and concave lenses. Then straight away we can start all the application types of lenses next day and finish it off, right? Quickly do it now. Quickly. Object is between f and 2f. Huh? F and 2f. Between f and 2f, like this. Between f and 2f. Okay, where's the final image? Where's the final image? Anyone? Quickly. Online? What about online? Where's the final image? Online ones? Anyone? Anyone? What about the online ones? Because I don't see whether you are drawing or not. Drawing the diagram or not. Online ones. Tell me. Where's the final image? If the object is between f and 2f. Object is between f and 2f. Where's the final image? Aisha, behind 2f. Good, correct. Tasmita, away from 2f. Good, correct. It should be beyond 2f. It should be beyond 2f. Right? This goes through the focal point. And this one should go through the optical center. Right? When dimensions in the sense when the measurements in your diagram is not that good, you are not going to get the exact correct one, right? So therefore, you can measure and draw this. You have to measure. You have to measure and draw this. Right. Apply sign convention minus plus. Right. And object is here O, image is here I. Distance from object to C is U, and image to C is V. U is plus, V is minus, F is minus. Same features, still inverted. That is still inverted, and that's a real image. Correct. What about the magnification? Magnification. Magnification. What about the magnification? Image distance is greater than object distance now because image is beyond 2f. Object is between f and 2f. Magnification is greater than 1. Greater than 1 means the image is actually enlarged, right? So in your one, you should see it clearly, right? M is greater than 1 within brackets, enlarged, right? And beyond 2f, location is beyond 2f. Location is beyond 2f. Location of the image beyond 2f. Location of the image beyond 2f. Clear? Right. Now, listen. This is the third location, right? Third location. If you compare the first location and third location, in first location, object was beyond 2f and image was diminished in between f and 2f. Now here, object is between f and 2f and the image is enlarged beyond 2f. Those two also follows what? Alternative property of light. Alternative property of light. First occasion nage reverse light rays gana hitala balan. Imagine the opposite directional light rays, reverse light rays of the occasion 1, that is exactly same as this, right? If the object is here, when light rays are coming, if the image formed here, if the object is here, image should form here. Alternative property. Got it? Mention in red below the third one. Below the third one, mention in red. Occasion 1 and 3. Occasion 1 and 3. Occasion 1 and 3. Occasion 1 and 3. Occasion 1 and 3 follows alternative property of light. Follows alternative property of light. Occasion 1 and 3 follows alternative property of light. Right. Occasion 4. Occasion 4. Write down. When object is kept at f. 4. 4. When object is kept at f. When object is kept at f. Quickly. When the object is kept at f. When the object is kept at f. Draw it quickly and tell me the features. Tell me features. Object is at f. At f. What are the features? Right. What are the features? where the final image is infinity. That is not going to form infinity. Yes, good. That is not going to form. That is not going to form. This is how it should be, right? So extend to this side and put this arrow as it goes up to infinity like this, and you have to extend it backwards as well, because in optics, if there are no real images, you have to check whether there are virtual images. Virtual images are due to virtual rays. Virtual rays means not the real rays, which means these kind of ones. Now from this side also, that goes up to infinity. So therefore, no image is going to form. No image is going to form. Theoretically, it should be at infinity, right? Practically, there is no image. Theoretically, it should be at infinity, right? Because if light rays are traveling until infinity, at infinity at least they should be intersected, no? So therefore, we call theoretically the image is at infinity, right? Now, only you can be marked. Only you can be marked. We cannot be marked, right? So therefore, in this case, u is plus, minus, plus. You can apply sign convention. U is plus, f is minus. About v, you can't say anything because we don't know at which side of infinity this is going to form. Got it? Right? And we can't write features because there's no image. Right? Okay, write down below with a red pen. Write down below with a red pen. Image is formed. Image is formed at infinity. Image is formed at infinity. Image is formed at infinity. Right? You have to extend both sides. And these are standard. Listen, what I can bear. These are standard. When you extend virtual rays, virtual means there's no ray in reality. Right? Right? The standard in optics is this. If you are using solid lines are for actual rays. Dotted lines are for virtual rays. Right? Then make a virtual in the dotted lines. Right? If standards, you have to follow them, you have to adhere to them. Real rays can actual rays solid lines, virtual rays dotted lines. Okay, next one, 5. When object is kept between C and F, 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 C and F, when object is kept between C and F. When object is kept between C and F, C is the optical center, so the object should be somewhere here, C and F. So then without knowing, we can't even say if the image is enlarged. No, we can't say. Theoretically, image should be same in size because they are parallel rays going to be converged there, no? Since the rays are parallel. Since the rays are parallel, it is going to be same in size, right? Theoretically same, but since there's no image form, really, we can't say anything. Okay, where's the final image? Between F and 2F, between F and 2F, same side. Any different answers? Between C and F. Ekathari. Cube ekathari. Right. See? Right. Now, from this side you can see, from this side, from this front side you can see, this is never going to be converged, right? That is deviating from each other. So therefore, if this side is not going to converge, check the opposite side, right? Extend these two backwards like this. Extend these two backwards. So somewhere here, they will be converged, right? Then at this point, see, now there is something here. Look at here. Two virtual rays are converged. If two virtual rays are converged, a virtual image is going to form. Real rays නැතුව real images හදන්න බෑ. Real rays වලින් තමයි real images හැදෙන්නේ. ටක් ගාලා එක මේකෙන් ඕනනම් ක්ලික් වෙනවා චෙක් කරගන්නත් පුළුවන්. From virtual rays, virtual images form. From real images form. Right? The image එක real නේ. So you have to draw the image with dotted lines. Image එක virtual. So like this, මේක තමයි හරි මේක. Image and the object. So with respect to the size and the dimensions of your diagram, this image can be anywhere behind the object. Right? That's what I said, as both are correct. Right? With the dimensions of your image, with the dimensions of your object, with the size of your object, and with the dimensions of your focal length and everything, this image can be formed anywhere behind your object, right? So that's why you are saying that is between F and 2F, that is between C and F. එහෙම වෙන්නත් පුළුවන්. C and F වෙන්නත් පුළුවන්. මේ beyond 2F සමහරලාට යන්නත් පුළුවන්. Right? That can be the only thing we can say for sure is that is behind the object only. That is behind the object. Right? තව ඇඳලා බලන්න ඕක එක තැනකට move වෙනවා. That is behind the object. Right? මම මේක තව පොඩි කරලා ඇඳුවොත් මේ image එක මේ හරියට ගන්න පුළුවන්. මේක තව ලොකු කරලා ඇඳුවොත් මේ image එක තව පිටිපස්සට දාන්න පුළුවන්. Correct? So therefore, you can't say any exact position for this image. For this image, you can't say any. One second. Right? You can't say any exact position for the image unless it's behind the object. Behind the object. That's it. Right? And this image is very much important compared to the other ones. Why is it? What's the difference compared to all other images we know? Sorry? Upright, before upright, this is the only virtual image we had. This is the only virtual image we had. Right? For upright images, using prisms also we can do, right? Using combinations of prisms and lenses we can do, right? But using a single convex lens, this is the only virtual image that we can have. Only virtual image. So this is special. Right. Okay, now mark these things. Object distance from here to here, U. Image distance from here to here, V. Sign convention minus and plus. Right? Signs, U is measured from this side to here, U is plus. Right? V is measured from optical center to the left, V is plus. Right? F is, now what is the active focal point? This one or that one? Right or left? Right. Right. If light rays are coming from this side, right one is active. Make active na. Make through negative. Right is active. So F is always minus. F is positive when na kohamat connex lens. F is always minus. Always minus. Huh? Huh? Sorry? Yeah, you're right features. Right features. I didn't write it. Right features. Features. What are the features? First one, upright. Upright, or you can say not inverted. Not inverted. Upright. Real or virtual? Virtual. The reason is, now if you try to keep a screen here, see what happens? If you try to keep the screen here, these two light rays are going to be blocked because these two light rays are not originating from here, right? These light rays are coming from somewhere behind. Right? Now, when you are looking at my image, right, the light rays which are coming from the object is, from object means from the body, is not originating from the body. No? Illuminate light rays and something like this. Light rays and they are coming from a distance. So therefore, if you keep the screen here, all these light rays are going to be blocked. No image is formed. Therefore, this is virtual. Right? Two things, two ways that you can verify the same. One is this image is formed using two virtual rays, no? Two virtual rays, which means that is going to be virtual. Right? And if you try to keep the screen, the practicability here is you can't keep the screen without blocking the incoming light rays. Right? That is virtual. Virtual. Right in red, this is the only virtual image we have in a convex lens. Right. What about the magnification? Magnification. Greater than 1. Greater than 1. Enlarged. Enlarged. And about the location, the only thing you can say is that is behind the object. Behind the object. When you change the size, it displaces for any point. It can be displaced for any point behind the object. Maybe between C and F or at F even. At F, Fn to F or beyond to F. Right? The only thing you can say is that is behind the object. Right? මේක එකයි දාලා තිබ්බේ එකයි. තේරම හරියද? Between F and 2F, between F and 2F, C and F, everything is correct. It should be behind the object. Okay, understood? Write down below with a red pen. This is the only virtual image. This is the only virtual image. This is the only virtual image. This is the only virtual image forms by, this is the only virtual image forms by a convex lens. Write in red. This is the only virtual image formed by a convex lens. Right. See, Now we have come to the end of all images formed using a convex lens. There is another pattern, a small pattern that you can observe if you check all diagrams from the first one. We started beyond 2f now, starting beyond 2f, and finally I have taken this up to between c and f, which means we have moved our object from starting from beyond 2f up until the region between f and c, right? Then image has started from f and 2f, මෙතනනේ පළවෙනි image එක හැදුනේ f and 2f, and it has gone beyond these points, right? So therefore, for real images, only for real images, there is also a pattern we have. And if you think further, the furthest point we can have is infinity. No? If the image is at infinity, if the object is at infinity, image should be at the focal point. Because if the object is at infinity, all the light rays which are coming from the object are parallel. If they are parallel, it should be forming the image, right, at the focal point. So therefore, theoretically we can say, when the object is taken from infinity to f, right, infinity to f, the image is going from f to infinity. Is it clear? If the object is at infinity, image is at f. If the object is beyond 2f, object is between f and 2f. If the image is at 2f, that is at 2f, right? When the image is between f and 2f, this is beyond 2f. When the object is at f, image is at infinity. Write down below again with a red pen. When the object is taken from infinity to f, when the object is taken from infinity to f, when the object is taken from infinity to f, image is gone from f to infinity. Image is gone from f to infinity. Image is gone from f to infinity. Right? Okay, listen now. And you better put some asterisk marks here, right? Since this is the only virtual image, right? So when it comes to questions, if it is given as a virtual image using a convex lens, right? The occasion is very straightforward because there is only one occasion. For real images, there are 3 occasions, right? Except the infinity, there are 3 occasions, but here this is only one. So therefore, more frequently questions are coming, and when the hints are given, you should be able to identify it as this scenario, right? That's the learning here. Okay, now this is everything about convex lenses. Any questions up to here? No? Online? Any questions up to here? We'll see. Just wait for another 2 minutes. We are about to start concave. Right? What about online? Any questions so far? If it's clear, put a thumbs up at least. Okay. right? All right, let's move on. Now, the next part is all about the concave lenses, right? As the next heading, write down significant rays for a concave lens. 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 Right. First scenario. These four occasions are also very much comparative for what you have drawn in convex lenses. Right. First one, what happens if a parallel beam of light falls? Right. We have already drawn these things. All the light rays are diverged as they are coming from, apparently they are coming from the focal point, right? F. First one. Take down. Now, these are all learnings we have taken from the initial diagrams we draw, right? From the initial diagram, the basic ones. Don't draw solid lines for the virtual rays, right? That's a standard. For virtual rays, that is only the dotted lines. For real rays, that is solid lines. Right? Second one. What is the second one? Very comparative. Very comparative. Second one is going to be the alternative property of this, vice versa of this, right? When parallel beam of light falls, if it diverges as it is diverging from the focal point, if light rays are fallen towards the focal point from this side, they should be parallel, right? මෙහෙම light rays යනවා නම් opposite light rays එන්න බෑ. That is what we call the alternative property of light, right? එහෙනම් මේක opposite එක අඳින්න යන්නේ මම. Second one, draw the exact opposite of this. Draw the exact opposite of this. If light rays are fallen towards the focal point, see, then they should be parallel after refraction. Should be parallel after refraction. Right? If needed, you can again mention this as ordinary property. Ordinary property. Third one. Very much similar to what you draw in convex lenses. This is the optical center now. Any light ray which goes through optical center will not be refracted. Any light ray which goes through optical center will not be refracted. Right? And the last one. Now here we have considered a parallel beam of light parallel to principal axis, right? And here we are going to consider a parallel beam of light inclined to principal axis, right? From this one also, from this occasion also that I am going to draw here, focal plane of a concave lens. I discussed a question in the last paper, in paper class, paper 4. Right. Right. Now, what if an inclined parallel beam of light falls like this? Inclined parallel beam of light, inclined to principal axis. Right. The point is here, we know any light ray which goes through optical center is not refracted. Now, from this set of light rays also, there is one light ray which goes through optical center. It won't be refracted. Now, if the focal point is here, say the focal point is here, if the focal point is here, if the focal point is here, this plane which goes through, vertical plane which goes through focal point is the focal plane. Focal plane, same terminology as before. Now, this light ray, which is not going to refract, is intersecting the focal plane at this point now. Then all other light rays are also coming to the same point after being diverged. See, after being diverged, it is coming to the same point. So in the last paper, the question was about a path of a light ray, after the refraction. Right? If you can't remember, say it after the class. It was a MCQ in paper 4. And compare these things with the convex lens. Very comparative, very much comparative. Okay, finished? Oh, come second day, okay, take down. Finished? Clear. Today we are going to finish the discussion of all the theory parts in lenses here. And next day we'll be starting all the applications. Right now, from here, all the theory parts are finished. Right? By the end of this class, even if you are not a regular student who is watching the YouTube live, right? So by the end of the class, you can make sure that all the theories are covered here, right? By today, all the theories are covered. Then you can practice some applications, some questions from past papers or from wherever it is, and check whether they are doable. And in the class, we are starting the questions next week, and next day will be a full day with questions of lenses applications. Finished? Okay, next heading. Next heading. Formation of images. Formation of images of linear objects. 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 By using concave lenses. Formation of images of linear objects by using concave lenses. Right. Same scenarios as before. Start now. Same. First one, when the object is kept beyond 2f. Same thing. Try color bar. And I'll show you a graphical representation of this meanwhile. Right. Try them. Right. Okay. Let me show you. Two minutes. Complete all five. Right. So until I do this, complete all five. What about the first one? What's the location? First tell me whether it's real or virtual. Huh? Real or virtual? Virtual. Location? That's the location? Huh? Huh? Between C and F. Correct. Okay. I'm going to show this from my personal laptop. Give me 1 second. I need to log into the meeting.
Recording in progress.
Right. Okay, the screen is visible, right? Look at here. Or shall I do the diagrams first and come here? No, moving convex lens when that is already done. See, visible rays, labels. Okay, one object is enough. Focal points are marked. 2F points are not marked here. I think it cannot be turned on. 2F option and no. Okay, see, start from here. Start from here. Now initially we started beyond 2F. No, see, this is somewhere beyond 2F. This is somewhere beyond 2F. Where on light fall now there's no light here. This is what happens when light falls. Right? Now the object is beyond 2F. Beyond 2F. Can we turn on the ruler? No, we can't. What is this? Now, if I take this from here to somewhere here, see what happens? The image is enlarging and moving away from the focal point. So that's what I said. If you are taking the image from infinity, right? If you are taking the object from infinity, image starts at focal point. When the object is taken from infinity to focal point, image displaces from focal point to infinity. Right? Then somewhere here it will be 2F. Then equal in size, upright, everything is there. Right? Then take it beyond F and 2F. See what happens? It is getting enlarged now. It is getting enlarged. Right? if there is at 2f, this is a special one. At 2f, see? That zoom out කරන්න පුළුවන් නේද? නේ? දැක්කද? That is never going to converge. So therefore, theoretically, it should be at infinity. Theoretically, it should be at infinity. Right? Concave එක ටික දැම්ම පෙන්නන්න ඕනේ නැහැ. ඒතකොට දැන් concave එක ඇඳලා ඉවර නැහැ. Right? 1 second. CNF. If this is taken from beyond CNF, see? Now the virtual image is coming from here. Can you see? Virtual image is coming from here. That's what I told you. Now you can't say whether it's between F and 2F or beyond 2F4, between C and FC. So when you change the location of the object, see how it moves. Right? That doesn't mean that it can be taken between C and F. It can be taken between C and F. Correct. Right. Make a race radical level. See? Last time. So that is what happens. Minimum 2 rays are required. Minimum 2. Right? Minimum 2. Minimum 2 rays are required. So I thought this light rays can be changed. No, light rays cannot be changed. Case Villain. No. Right? So this is the only virtual image we have. Only virtual image. On our website, check you can play around with this and check what happens when the focal length is changed. Right? When the focal length is changed, when the height of the object is changed, height of the images, height of the object, right? And image distances, everything. When those things are changed, you can see what happens here, right? Thanks. Now let's go to concave lenses. Right. I'll be stopping sharing for a moment. Okay. So what about the diagram 0? First one, beyond 2F, when the object is kept beyond 2F, right? So check with your diagrams. Now I'm going to roll at once since I gave you enough time, right? F, 2F, F, 2F. Object is beyond 2F. Object is beyond 2F. Let's say somewhere here. You can use a parallel ray. Parallel ray goes through the focal point if extended. And as a second ray, you can use a ray which goes through optical center. So this ray goes through optical center. Right. Now, here there is another specialty. One virtual ray and one real ray is intersected now. One virtual ray and one real ray are intersected now. Right? One is real and one is virtual. Object is going to be real or virtual? Virtual. Right? Even if there is only one virtual ray, the whole image is going to be virtual. Right? Practically check since this is virtual, it should be dotted lines. If you are checking it practically, try to keep a screen here. If you try to keep the screen here, both these rays are going to be blocked by the screen. It is virtual, cannot be taken to a screen. Got the point? Now, in terms of rays also, you can say having just one single virtual ray is going to form a virtual image. Right? Image object is here, image is here. Object distance V is from here to here. Image distance U is from here to here. Right? Active focal point is here. So U is, apply sign convention, minus, plus, U is plus, V is also plus, F is also plus. Right? And write features. Features of image. Same four features. Same four. First one, inverted to upright, not inverted, upright. Inverted kill nahi. Upright. Real or virtual? Virtual. What about the magnification? Less than 1, diminished. Less than 1, diminished. Location. Between F and Z. Right? Between C and F or between F and Z. Between F and C. Between F and C. Second one. At 2F. Second one is at 2F. Apa hamane mang adinne kila kiwe? Ye bhai andala balan. At 2F. තුනක් විතර අදින්න තේරෙයි මොකද්ද වෙන්නේ කියලා. At 2F, one is this one and this is the other. The object is here, still virtual. Object is here, image is here, still that is virtual. Right? And all these things are same. So I'm not going to write again. This is exactly the same. This is exactly the same. Same. Exactly the same. Right? No need to write again. Same. Same. Right? Third one, between F and 2F. Between F and 2F. F, 2F, between F and 2F. F, 2F. That is also the same. Right? That is also the same. If you draw other two also, they are also going to be the same. Right? ඇඳලා බලන්න. අද විතරක් ඇඳලා බලන්න. ඊට පස්සේ මතක තියාගන්න ඕනේ. at F. At F. And finally between C and F. Between C and F. Image and the object. Right? So this is a very special scenario. Irrespective of the location of the object, all the features of the image are same. Right? Whereas in a convex lens, it changes from region to region. But here for all regions, it's same. Right? A very special case. Check your diagrams. Finished? Arrowheads are known. Sorry. Put arrowheads. They are virtual images. Use dotted lines. Virtual images. Use dotted lines. Right? Okay. So what's the conclusion? Conclusion is wherever the object is kept, image is always going to be diminished, virtual, between C and F, and upright. Same features. Same features. Now, wherever the object is, the image is formed. No? So that's why, have you seen concave lenses are used in doors? අර ඩෝ එකේ මේ එළියෙන් ඇවිල්ලා ඉන්න කවුද කියලා බලා ගන්න පොඩි කන්කේව් ලෙන්ස් එකක් ගහලා තියෙන සමහර ගෙවල් වල දැකලා නැහැ. ඒ කන්කේව් ලෙන්ස් එක. ඒකෙන් බලලා නැද්ද? බලලා නැත්නම් try එකක් දෙන්න එහෙම එකක් හම්බුනොත්. දැන් ඒකට convex වගේ එකක් use කරන්න බැරි. What if that person in front of the door is at F? No image is going to move. බලා ගන්න බෑ. කේස් එකක් තියෙනවනේ. ඊට සමහර images real. ඒක තමයි අනිත් කේස් එක. real image එකක් බලන්නේ කොහොමද? To observe a real image, there should be a screen. And a screen එකක් නැතුව by the naked eye you can't see a real image without having a screen. එතකොට දැන් මිනිස්සෙක් ආවට පස්සේ screen එකක් අල්ලලා පොඩ්ඩක් ඉන්න කියලා එහෙම බලන්න බෑනේ. Convex lens එකක් ඒකට practical නැහැ. So that's why concave lenses are used. මිනිස්සයා කොහේ හිටියත් ගාන්ට යාගේ image එක පේනවා. Right? Lenses using doors. Door වල දානවා. Doors වල දානවා. Okay, finished? Write down below with a red pen. Write down below with a red pen. Right? All are same. That's a conclusion. All are same. Write down with a red pen. All images formed due to concave lenses. All images formed due to concave lenses. All images formed due to concave lenses. Within brackets, for real objects. Now, these are real objects. Huh? Real objects may consider. There is something called virtual objects. Right? Next day, virtual objects can diagrams virtual objects. These are real objects. In reality, these objects are there. They are real objects. For a real object, the image is virtual. then according to the alternative property, right, for some, I mean, from somehow, if there was a virtual object, the image is going to be real. Vice versa, alternative property. Right. For real objects with close brackets are, put a comma and mention these points. First one, upright, within brackets, non-inverted, not inverted, within brackets, not inverted. Second one, virtual. Third one, diminished, within brackets, m less than 1, m is less than 1. Fourth bullet point, between f and c, between f and c. Right. So from here, listen, from here, all the theory parts of lenses are finished, right? Now to do all applications, you have to know everything from the very beginning to here. Everything is connected and everything is going to be used in applications, right? Okay, now let's see what happens with concave lenses, right? See. You can see the screen, right? Right, now from here, if we don't use an arrow, මේ වෙනස් කරන්න පුළුවන්. පස්සේ ඕනනම් බලන්න කරලා. හරි. අපි මේ linear objects විතරයි නේද තියෙන්නේ. That's why I use an arrow. Otherwise, for 3D objects, this is how it is going to work. See? Real means that should be on the screen. මේක එක options තියෙනවා. ඉතින් කරලා බලන්න. That is virtual. ඔය screen එකක් නෙමෙයි තියෙන්නේ. paid කරලා තියෙන්නේ. Right, මේක එක එක තියෙනවා. These are asymmetric objects. Because in asymmetric objects, it is going to be mirrored as well. That's why. මේක මම questions වලින් කියලා දෙන්නම්. It is going to be mirrored. මෙයාගේ beak එක දිහා බැලුවොත් beak එක මේ පැත්තට තිබ්බනම් මේ පැත්තට හැරෙනවා. ඒක mirror වෙනවා. Right, මේ ඕනම් මේක බලන්න පුළුවන්. This is not just inverted but mirrored. Now for today we are with the linear objects only. Right. Now about the concave lenses. This is the image. Now I'm going to start somewhere here. The virtual image is between f and c. Right. We are taking this from here to here to all the way up to this point. Still, that's virtual and all the features are same. All the features are same. Right? Significant rays බලන්න ඕන නම් මෙහෙමත් පුළුවන්. If I take this to somewhere here, I want to make it phenomenon. See, if you need to check the significant rays, like a principal level, when this is taken to here, see, parallel ones, and the light ray which goes through C, right, not refracted, they ඔක්කොම බලන්න පුළුවන්. Right, many එක දැම්මම then you can see marginal දාන්න පුළුවන්. Marginal means they are the inclined ones. Marginal එකෙන් බලන්න පුළුවන් the way that they are converging at the focal point. ඒක බලන්න පුළුවන්. එක එක තියෙනවා පස්සේ කරලා බලන්න. Right? Okay. Hold on here. website එක දන්නවනේ මම කලින් දැස කිව්වනේ මම මේක කලින් හැමදාම use කරන්නේ ඉතින් phed.colorado.edu that thing, right? When you type phed dot it comes, right? If you type phed dot it comes, right? කරලා බලන්න එක එක තියෙනවා අපේ experiments ගොඩක් මේකේ තියෙනවා in physics. Waves වලත් මම පෙන්නනවා මතකද? Simple harmonic motion, waves, everything. Right. Okay. Any other questions? Any other questions? මේ radius of curvature එහෙම ඕන නම් වෙනස් කරලා බලන්න පුළුවන්. What is happening? මේ focal point decreases එක තියෙනවා. Refractive index කරලා බලන්න. Because those applications are also there for us also, right? Next day you will see what happens when thickness of a lens change and when the height changes and the thickness changes, different things are there, right? Any questions? No? All clear? All right. Online students? Dylan, I forgot to tell you, can you take another shot? Right. So meanwhile, ask if any questions, online students. The thing is, I didn't even see the diagrams you draw, the online students. That's why I'm asking, right? So I hope you have used rulers when you are drawing the diagrams and you have done everything perfectly as this. Is it all clear? So put a thumbs up at least. Yes, clear. Okay. All good? Okay then. Right. Okay, then as we planned today, now we have come to the end of the all theory parts of lenses, right? All the theories are finished, right? That doesn't mean that you can do all the questions in lenses, right? You know all theories, right? But if you didn't go through these theory parts, right, I'm sure that you are going to forget these things, right? Now, as the learnings of these things, you have to know features. Now, if I ask the features when the object is kept between f and 2f, you should be able to say all features and you should be able to imagine the ray diagram. Likewise, that's a learning outcome here, right? That's the outcome. You should be able to recall these features. Features are especially in MCQs. Questions karaddi balamu. Right? You don't get any chance to draw the diagrams and check features. Right? එහෙම කරන්න පුළුවන් MCQ එකකට ඉතින් ඒතකොට MCQ එක කරන්න පුළුවන් විනාඩි 10ක් විතර. but වැඩක් නැහැ. You have to know all features. Right? Knowing all features is a must. Right? That's the learning outcome here. Ray diagrams, features, signage, sign convention, everything. ඔය ටික තමයි මෙතන main core එක. And using this, we are going to go into the other applications, right? Okay then, so go through again and it's better if you can practice these ray diagrams again and again, few more times, right? Until you are familiar. Take a rough sheet or something and practice these diagrams again and again until you are familiar, right? Make it best case. All right then. Then there are no questions. We'll wind up. It's 7:45. Right. We'll wind up. And next day it will be a full day we are going to spend with the applications of lenses. And by next day, lenses are going to be finished. And the third week, we are going to start defects of vision. It's a small lesson. And then the last week, by the last week, we'll be doing optical instruments. That's a lineup. Right? All right then. So if anything that you need to clarify further, you can drop me a message later on after the class. I mean, if you get any questions after the class. Right. Okay then. Then go safe and stay safe these days. Again, for the Central Highlands, it's raining. Right? Started to rain and it's raining and landslide warnings are issued again. and some people are evacuated, right? So things are happening around, right? So be safe and work hard. You are just 8 months ahead of the exam now. 8 months. August, if the exam is in August, we are just 8 months ahead of the exam, 35 weeks. Okay then, go safe and see you all in the next class. Good night and goodbye.